Hi students, how are you all? How's the energy? Great? Little low? Yes, I can understand exam tension, fear, anxiety, isn't it? So don't worry, we'll remove this video, will definitely remove all your tensions, fear, anxiety, and will ensure that you will get that confidence to face the exam gracefully and boost up your energy level for sure. So we'll just start the session. I'm Shilpa here. We'll do the PU2 Midterm Computer Science complete revision. Okay? So we'll start with the first chapter, that is called exception handling. So before we, we'll just go with the flow, what is there in this slide. So we'll just understand what do you mean by exception handling. Okay? So here, so what exactly you mean by exception? And we'll just divide this entire word exception handling into two parts, that is exception and handling. So what is exception? Exception is basically an error that disturbs the normal flow of execution. What is exception? Exception is an error that disrupts the normal flow of execution. I can also say it is basically a Python object. What? It's basically a Python object that represents an error which contains information like the name of the file where the error has occurred, and then the position where exactly the error has occurred, and the suggestion, the error type, and all the details related to the error will be shown. Okay? What is an exception? It's a Python object that represents an error that gives you all the information related to the type of the error, the file where the error has occurred, the position, the suggestion, how to overcome the error. Okay, that is what you mean by an exception. Now, what do you mean by handling? Handling is basically how do you try to solve that, right? So, how do we handle these errors? What is exception handling? Very simple. Handling of errors is called as an exception handling. So now we'll understand what is the need of exception. What is the need of exception handling? Why do we have to study this chapter called exception handling? Very simple. The definition itself says that exception is that disrupts the normal flow of execution. We don't want it to get what I can tell you. We don't want it to get crashed. We want the normal flow of execution. Rather, I can say that, right? So what is the need of exception handling means? It's basically to have a normal flow of execution, and basically to prevent the program getting crashed, increases the program readability, and also it helps in debugging. So that's why we have to study this chapter called exception handling. Is the point here? So now we have learned what is an exception. What do you mean by exception handling? Handling the errors that occur during the execution of the program is called as an exception handling. Now, we have to understand the different types of exceptions and all. Okay, if you have to tell me the definition, the formal definition, okay, if you have to tell me the formal definition of exception handling, it's basically a useful technique that captures the runtime error. It's a useful technique that captures the runtime error and basically gives you a message. It gives you a message, proper message to the user on encountering the error. So what is exception handling? It's a useful technique in capturing the runtime errors and gives you an appropriate message on encountering the error. Then how do we do it? That means basically by adding a block of code. By adding a block of code. By adding a block of code, we can handle the exception very easily. So then we have to say somewhere that this is what I'm handling the exception. That means the interpreter need to understand this is basically a code related to exception handling. That means we need some certain keywords, right? What are the different keywords that are used? It's basically try. There are certain keywords that basically tells you about the exception handling. That is try. Then we have except block. Then we have an else block. And also we have finally block. These are the keywords that are used for handling the exception. So I think you have a clear idea on exception handling. Clear? So now we'll just go for the next slide. So here in this topic you have types of error. So now you've understood what is exception, exception handling and all. Now we'll understand what is an error. Now we know exception is basically an error only. Exception is basically error only. So what is an error? Error is basically an unwanted condition. Unwanted condition or unwanted situation that arises when we execute the program is called as an error. Okay, the error and exception are basically that that occurs when the program is under the execution. Okay, that basically arises when the program is under the execution. But the severity, how is it different? It basically differed by the severity, originality, and also with respect to the way it is handled. That's how there is a little difference between the error and the exception. Okay, so in this chapter, according to your syllabus, we'll just focus on error. So what is an error? Error is basically an unwanted condition or unwanted situation that arises when we execute a program, Okay, so here normally what we have seen, the different types of errors. So far what we have seen from our first PUC syllabus, we know there is a syntax error, there is a runtime error, there is a logical error. So what is a syntax error? The error that occurs when it violates the grammatical rules of the programming language. That violates the grammatical rules of the programming language is called as a syntax error, and that occurs before the program is executed, before the program runs. It's called as what? It's called as syntax error, or it's also called as compile time error. It's also called as parsing error. Also called as parsing error. So now let's come back to this second error called as a runtime error. Runtime error is what basically the exception. Then syntax error is not an exception, but according to your textbook, syntax error is also considered as an exception only, but exception mainly deals with the runtime errors, not the syntax error, nor the logical error also. Basically, exception mainly deals with the runtime errors. When the program is executing, whatever the errors that crop, those are called as in runtime errors. Okay, detected during the program execution. Next is what? Logical error. So what is the logical error? Logical error will not give any kind of error. And then how is an error? It will not give you any kind of error, but it will give you inappropriate results, incorrect values, not according to the expectations. Okay, it will give you some incorrect results it will give. So example is what? If you, for example, I want to add sum is equals to a plus b, I wanted to do it, but instead of this I have just multiplied it. Wrong usage of the operator. And I have to assume that sum should be equal to 0. Instead of assuming the sum equals to 0, I have made a different assumption, sum equals to minus 1. I have made sum equals to 1. Some other assumption I have made it. Faulty logic. This leads to logical error, and it is very hard to detect. You should be very thorough with the logic part, only then you will be able to rectify the logical errors. This is the main types of errors that what we have learned so far. Okay, so we'll go for the next thing, that's called built-in exceptions. Okay, built-in exceptions. Exception, you know what is an exception? I told you in the previous slide only. It's basically an error that disrupts the normal flow of execution, especially the runtime errors. Even according to your textbook, you should understand that syntax is also kind of exception only. That's why they've included this also under this. Keep that in the mind. Clear? Now, what is built-in exception? So exception, you know, what is this built-in exception now? Exception is basically classified as built-in exception and also user-defined exceptions. What do you mean by built-in exceptions? Built-in exceptions means commonly occurring errors which are identified by the interpreter. Commonly occurring errors which are identified by the interpreter are called as built-in exceptions. And remember one thing here, it is automatically triggered. On encountering the error, the interpreter automatically triggers these errors. Okay, automatically it gets triggered. Those are called built-in exceptions. We have some user defined also, let's not go in detail because that is not there for the syllabus. I just told you there are two types of exceptions. Okay, so exceptions, two types, built-in and user defined. We'll go for built-in exceptions. Under built-in exceptions, there are so many built-in exceptions are there. Let's just go one by one. Okay, what is this? We have a syntax error. Syntax error, as I already told you, it's basically that violates the rules of the programming language is called as a syntax error. And in this case, what do we have? Let's take an example. If we, for example, let's take print. Okay, we're just telling you with respect to the built-in exceptions. Built-in exceptions are commonly occurring exceptions, commonly occurring errors that are defined by the interpreter and they are automatically triggered. Okay, are automatically triggered. Those are called built-in exceptions. What are the different built-in exceptions? So we have a syntax error, value error, IO error. There are so many errors. We'll just go one by one. We'll just go for the syntax error, which violates the grammatical rules of the programming language, are called as syntax error. So what is the example? We'll just take one example. Okay, we'll take print. So I'm going to take print. Okay, so I'm just going to write its quote here, double quotes. Okay, happiness is within me. Okay, I've just written one statement here. Print happiness is within me. Let's find out. Any error? Definitely it's an error. We have missed the quote here. It's a double quote. We have begun it. Okay, we have started with the double quotes, but have not ended here. So missing of parentheses, missing of double quotes, so missing of colons. Any grammatical violations of the programming language leads to syntax error. Okay, next what we have a value error. So what is value error? When there is an inappropriate entered for a particular data type, it leads to value error. What is the example? Let's take another example here for the value error. So what's the example? Let's take a equals to, okay, int input, enter value. Okay, and I've entered. Okay, there is a prompt here, enter the value. And what is the value I have entered? I have entered as love all. I've just entered, it has given me the prompt, I've entered as love all, and it is basically a string. So input function, it's take a string and that will be converted into int. Now this love all should be converted into int. It's basically an integer. String has to be converted into int. It is not possible. This leads to an error called value error. Now we have an IO error. What is an IO error? If the file cannot be opened, it leads to an IO error. Okay, input output error we call it. Okay, similarly we have an keyboard interrupt raised when the user presses keys like escape that interrupt the program flow. Okay, if you just press from escape, it leads to the keyboard interrupt error. Then we have an import error when the module is missing. For example, we have come up with lot many modules. Math module is there, random module we have pickle module, we have lot many modules is there, no? So if you miss the module name, I want to use in square root, but if you miss that math module only, then definitely it leads to a module error. Then we have a zero division error. So it's raised when dividing the number. So for example, 10 by 0 if I give, definitely it leads to an error called zero division error. Please remember here the spelling. Everywhere it is being highlighted. Every word, the starting letter of every word is being capitalized here. Write it in the same way. Zero division error. Okay, keyboard interrupt, IOE error. Then we have value error, syntax error, EOF error. What is EOF error? End of file. So you've already reached the end of file and you're trying to read something from the file. You've already reached the end of file. There is nothing more to read it. It leads to an error called EOF error. So we have an index error. So index error is basically when it goes out of the sequence. Let's take one list here. List 1, 10, 20. okay, and 30 I have taken. Okay, this is basically a list, and we have an index for 10 is what? This is the index is going to be 0, 1, and 2, and I'm trying to access 10 of L of 4. L of 4 is what? There is no 4. I have not stored anything in the index 4. That leads to an index error. Name error. So let's consider they have taken a is equals to int input, enter the value, and now let me consider that this I've removed it. Int is not there. Okay, I've stored love all in the variable a, the string variable a, and you're trying to print b. What is there in b? If not at all define what is b and how you're trying to get the output of trying to print the value of b, there's nothing. You've not defined only. That leads to an error called name error, and we have an indentation error. So let's write one example for the indentation error. So what's the example? So I'm going to take an example. If a is equals to okay, I am positive. Okay, print positive. Very simple. What I have done, I've just taken a variable called a, one string variable I've taken. I'm trying to equate it. I'm going to check whether the value of a is going to be, I'm positive. I'm checking it. I don't know what I've stored before only. Okay, just assume that I've already stored. Okay, I've stored it. If it is so, I have to print this. Okay, I'm positive and print positive here. If it is true, I have to print this positive, then definitely it leads to an error only, because you have to follow the indentation. That's very, very important. It's basically a block here. It's an if block here. This has to be placed here with a spacing. The leading, what is indentation? It's basically the leading white spaces at the beginning of the statement that indicates that this statement belongs to a particular block is called as an indentation. So you have misplaced the indentation here. That leads to an error called indentation. And we have a type error. So what is the type error? Let's consider 4, and you're going to add with 4. Okay, so what is this? 4 is an integer, and you're trying to add an integer with a string. It's not possible. Plus is basically an operator. You can add with the numbers. Okay, you can concatenate the strings, not with integer and the string. So it leads an error called type error. And similarly, we have an overflow error. So raised when the result of a calculation exceeds the maximum limit for a numeric types. Okay, for example, I'm going to take a value of a. A is equals to 10 star 1000 or 10,000, something like this. If it reaches, okay, if the particular value of a variable, integer variable, if it exceeds the maximum limit of a particular data type, it leads to an overflow error. You can look at the spelling O capital, E capital. It leads to an error called overflow error. Okay, we'll go for the next. Okay, so we'll come to the next slide, that's rise and assert statement with syntax and example. See, in the previous slide, you've already seen there is a built-in exception. What is built-in exception? The commonly occurring errors that are defined by the interpreter are called as built-in exceptions, right? Automatically triggered. Automatically triggered is one kind of an exceptions, and similarly we can have exceptions which are forcefully triggered, manually triggered. Okay, so the errors which are manually triggered or forcefully triggered using the keywords called rise and assert. Manually errors also can be triggered, exceptions can be triggered. According to our requirement, we have to have some kind of a message to be given to the user. So we can have such kind of exceptions to be created. So we have that, what is that? We have that facility for us to create the errors manually using a keyword called rise and assert. Okay, so use definitely it throws an exception manually. So how do we write it? Very simple. I'm going to write if. Okay, let's take a is equals to int input, enter the value. Okay, int input, enter the value. Enter value. Enter value, and if a is less than 0. rise exception, age cannot be negative. Age cannot be negative. Okay, very simple. I have just written one statement here. Int a is equals to enter the value, enter the age of a person. Let's consider here. And after taking the value of the age, I'm just checking if the age is less. For age only you can consider. A is less than 0. If it is less than 0, you can clearly say that it's negative. It's negative, you cannot enter the value, right? For example, let's consider that you're trying to register for some particular website, IRCTC website, you're registering and you got stuck up in the middle, like you're trying to give the password, it is not at all accepting, and it is giving you a kind of blank space without any kind of suggestion, suggestion box as such, like what you have to do next. Okay, but in case it clearly says that the password should be of so and so length. Okay, it should be some one specific special character should be used. One character should be a number and one character should be capital. If they clearly send the message, proper message if it is sent, then it is easy for the user itself will be able to handle that error. That's why handling the exception is very, very important. Clear? That can be given. This is manually we have to give. No, it's not built-in exception. If the A is going to be negative, how the user will get to know, how the programmer will get to know, how the interpreter will get to know, it should not be negative. So we have to tell, we have to write it in the program, right? So similarly, if we write A equals to enter into the value, if it's negative, we can just say that rise exception age cannot be negative. Automatically, this statement will be executed. This statement will be executed. Is the point here? So similarly, this is the syntax, this is the example here. Oops, an exception has occurred. No condition, nothing is there. Simply if I give rise, it will come. No condition, nothing is there. Simply if you give, then also it will come. That is basically to rise or throw an exception manually. Similarly, we have an assert statement here. What is that assert statement? Assert statement basically is going to check the condition. It's going to check the condition. If the condition is false, it's going to rise the exception. If the condition is false, it is going to rise the exception. So let's take an example. I'm going to take x is equals to positive vibes. Okay, I'm going to write like this. X is equals to positive vibes. That means it's basically what? It is basically a string being stored in the x. String is being stored in the x. It is not comparing. It is being stored here. And I'm going to check assert x equal to positive vibes. Assert means we'll definitely check the condition. It tests the expression, sorry. It's going to test the expression. The expression says that x equal to positive s, definitely it is positive y, it is not going to generate any error. In case, if I write assert x equal to negative vibes, if I write x equal to negative vibes, then it is going to give a error. What kind of error? Assertion error it is going to give. It simply gives an error. It's going to execute, it is going to rise it assertion error only if the expression, it leads to a false. If it is false, this is false, it leads to an error called assertion error. Clear? So we'll just go to the next slide. So now I just told you what is an exception handling, everything I told you. Now now the point is exception handling is basically adding a block of code. Okay, basically to give a proper message or instruction to the user on encountering the error. So how it is given, how you're telling the interpreter, I'm handling the exception here by making use of some keywords, right? So which are the keywords? We have try block, except block, else block, manually block. Try block is what? It's basically an error causing instruction. Error causing instruction, error detection codes, I can tell you. Okay, wherever the error is, it may come. Here you have to remember that in order to handle the exception, the programmer should anticipate. Here error can come. He has to anticipate before only, in advance only, he has to He has to understand that error may crop in here, then only he'll be able to handle the exception. So he has to anticipate that. Only then he'll be able to handle the exception, right? So here error causing instruction will be written in this try block, and similarly error solution, okay, solving the error, okay, error solution code, I can tell you, error solution code will be written in the except block. And similarly, if there is no error, see, executes if no exception is raised, there is no exception only, and then else block will be executed. Irrespective whether an exception is there or not, this block will definitely get executed always. And remember, if any error has not been identified, it re-raises the exception also. If you have not addressed, then it is going to re-raise the exception in the finally block. Keep that in mind. Clear? Okay, so we have an example here. Let's look at the example also. We'll be able to understand in a better way. So we have written a try block. Try block contains what? Error detection code, error causing instruction. So that means here where the error can arise. Students, it's a very simple chapter. If you can write this example everywhere, you will definitely get the marks. Okay. So what is a simple example they have taken? Just divide by 0 only they have taken. This is 0 division error only they have taken here, and also value error they have taken. Numerator equals to 50. Okay, enter the denominator. If you are trying to divide numerator by denominator, division performs successfully, and in case the denominator you have entered is 0, 0 means automatically the interpreter itself rises it. But you don't want the error message, whatever the interpreter is showing, you want your own customized message to be displayed. Means you can just handle it in the except block. Except 0 division error, denominator is 0 is not allowed. You are clearly telling us denominator don't put 0, no, don't put 0 there, simple. And for example, you have put enter the denominator, instead of that you have entered as you've instead of entering the denominator value as in terms of integer, you have given in terms of what I can tell. You have given something as good. You have just given the statement as good. That means it's basically a string. It leads to end value error, only integers to be entered. Okay, and let's consider that you have entered it's 50 and you've entered the denominator as 10 here. So it is not a 0 division error also. It is not a value error also. It definitely comes here. It calculated the value of quotient here. Okay, it calculated the quotient, and you're going to display the value of quotient in the else block. Else block is going to execute when there is no exception. Clear? This will be executed, and irrespective exception is there or not, this will definitely be executed. Finally block. Keep that in the mind. Okay. I told you what is an exception handling and need of exception handling also. Exception handling is basically an adding a block of code basically that gives you a message or an instruction to the user to on encountering the error. Okay, on encountering the error to overcome that error. And need of exception handling, basically what I can tell you, it's basically to have a normal flow of execution, to prevent the program getting crashed, and also we can say that it increases the readability of the program and decreases the what I can tell you, that overhead, okay, unwanted messages being given out, that basically it reduces it. Okay, so it can be applicable for both user defined as well as built-in exceptions. Yeah, so we'll just go for the next chapter. Okay, we'll start with the second chapter, that's called file handling. So before we'll start with the text files and binary file, we'll just understand what is a file. So what is a file? I think so far what you have understood is you know how to store your details. For example, like I just want to store the student details. For example, name of the student I wanted to store, and then the combination, and then the like which class you are in, and then the percentage or something like that I want to store it. And then that means you can just have a list or a dictionary or tuple, and you can store this information. Okay, you have stored your details. Let's consider Radha. Let's consider combination PCMC, and then class is second PUC, and percentage is 98%. Now similarly, I want to store some 50 student details like that. I want to store all these informations permanently. I don't want you to write the code, execute it, watch it, and again if I want to see it, again you write it and then you store it again. No, I don't want like that. I wanted once I write the program, once I, give the instructions, give my details, it has to be stored permanently. Permanently means what, students? That means whatever the details, it has to be stored in the secondary memory. Store the details in the secondary memory. So how to do it? Very simple, make use of the file concept. So what is a file? File is basically a named area in the secondary memory. Named area in the secondary memory, the way we can store the data and retrieve it for the future purpose. That's what you mean by file. Okay, so we'll just understand what are the two types of files. We have a text files and we have a binary files. So what are the two types of files? A text files basically stores the information in terms of ASCII characters. Okay, you have to remember here, in case of binary files, it's going to be in terms of binary only, zeros and ones only. Okay, so it can be in terms of images, audios, videos, or so on. And similarly, we have each line is terminated by an AOL. That means slash in character. It can be anything. Apart from this, it can be slash t or slash n or anything it can be. There should be a separate slash n after every line. But there is no such delimiter here in the binary file. Okay, and it's easy to understand, right? It's going to be easy to understand. It's human readable. It's difficult to understand because it's everything in terms of zeros and ones. It's difficult to understand. An extension we have .txt, .py, .csv. Okay, and then we have .dat, mp3, images. These are the examples for the binary files. So we need a character translation. Translation is required because the way we have written and the way it is stored in the memory, definitely it is differing. So here in case of binary file, there is no translation required as such. Okay, we'll go for the methods in file handling. What are the different methods in file handling? So in case of the functions that are, methods are basically the functions only. Before we understand the syntax and example, we'll just go through with the meaning of all those functions. So what is an open function? Basically opens a file if it's already there. If it is not there, it is going to create a new file. Not there, it creates a new file. And close function is basically releases the memory. Whenever we open a file, there is always a file object associated with that. It's going to release that object. Okay, it's going to release that object. It's going to free the memory. That's what the meaning of it. Releases the space that is allocated for the file object. Similarly, we have a read function. It reads a specified number of bytes. It reads a specified number of bytes. And similarly here, read line, it basically reads one complete line from the file. Okay, up to the new line character. It can also read a specific number of bytes. Read line can be a specific number of bytes and up to slash and also one single line also it can read. Is the point clear? And similarly here, read lines is going to read all the lines. Output for this is going to be what? Strings only. Read and read line is going to be string only. Read line function, it basically returns as a list of string. It returns a list. Returns as a list. Reads all the lines and return them as a list of strings, which where each ends up with a new line character. Keep that in the mind. Okay, if you give the argument as negative for read or read line, or it's going to be in terms of no arguments only, then complete file will be read. That's the difference. Okay, we have write and write lines function. It basically writes a single string to the text file, writes a multiple strings at once. I know, okay, you can write multiple lines to a text file at one shot. Then I have to have multiple strings. No, how to store multiple strings? Multiple strings you have to store it in means you need to have some kind of iterable objects. Like what? List, tuple. So you can store multiple strings in the form of list or tuple in terms of iterable objects, where we can store multiple strings in the text file using a function called write lines. We have a tell function. I told you an open function will always give the object, file object it gives. The file object basically, okay, will be pointing every time. When you read one character, it just incremented by 1. If you write one character, it gets incremented by 1. So this tell function, basically it gives an integer representing where exactly the file object is there in the file. So we have a file here. See, what is a file? File is basically a named area in the secondary memory. In the secondary, there is a secondary memory. So we have a file here. So I have just written here, okay. So it just gives you, so right now my file pointer is here. So it gives you the integer, returns an integer where exactly the file pointer is pointing to in the file. Can you move the file pointer according to your need? Definitely you can move the file object according to your desired location, making use of a seek function. Making use of seek function, you can take the file object wherever you want it. Similarly, we have a dump function and we have a load function. It's basically used for serializing and for deserializing. Okay, this will be covered in the coming slides because little bit extra information I need to give before I tell you what is dump and what is load. Okay, we'll go further with open clause. Open function basically a function that opens a file. Okay, if the file is not there, it's going to create one new file. Whereas with open function is basically a clause wherein the file gets automatically closed when it comes out of the block. Okay, so what I can write is, I think it's there in the previous slide only, you can just check it here. See here, you can just check here with open. Okay, name the file and we have the file mode here as my object is a file object. Automatically this is the block. When it comes out of the block, that means that the control comes here, automatically the file will be closed. No need to explicitly close the file. That is the difference. No need to close the file explicitly. That is the difference. Clear? Yeah. So we'll go for this now. So what are the different methods? Whatever we have seen, we'll just see with the syntax and then the example here. Open function will always give you the file object. Is the file object. Is the file object. And here we have an example, sample.txt R. R is a file mode. Okay, so we have a close function. Any function, very simple students, any function you should always open any file related function with respect to the file object. Okay, apart from that serializing and deserializing, dump and load, remember rest of all the functions starting from the close function, okay, starting from that till the seek function, you can just see here everything we're going to use it, or we're going to use that particular function making use of file object only. File object dot close function, file object dot read function, file object dot read line function, file object dot read lines function, file object dot write lines, tell, seek, like this. Remember, I told you seek is basically a function that's going to give you wherever you want to move the file object, you'll be able to move it. From where you want to move, is it from the beginning, is it from the current, is it from the end, where exactly. That reference point is given in terms of reference point here. This reference point can be 0, 1 or 2. It can be 0, 1 or 2. It can be 0 means it's from the beginning, it can be from the current position or from the end. Okay, the corresponding example are here, they have close, read lines function, read lines. All the lines will be read here. And f dot write Python one string, multiple strings using interpretable objects like list here. Tell function returns an integer here, 5, 0. From the beginning, 5 bytes it will be moved. Okay, that is what seek function does. Okay, so we'll come back to this dump and load. Okay, we'll just go for this now. So we have a file open modes. What are the different file open modes we have? Okay, so we have different file modes here called R and R. Let's basically discuss the main important. Okay, R is there, W is there, and A is there, and that's all repeated. R is for what? It's for the read mode. And what is W? It's for the write mode. And what is A? A is for the append mode. So whenever plus is there, it means both read and write. So if I write R plus R plus R or R plus, it can be, it can be R plus, it means to say read write both. Plus W or W plus, it's read write both. P indicates it's binary, as simple as that. R is for reading, W is for writing, A for appending. If you have plus means it's both read write, and what is B? B for is binary, just remember that. And what is file offset position? Okay, whenever you open a file, what happens? Okay, there is a file object associated with that particular file. Okay, it gives you that particular file object. Where exactly that file object, the position of the file object is indicated by this file offset position. You read it, you want to read a particular file, that means to say that is the default file mode that we will be having. Default mode, as soon as you open a file without giving any mode means what? It will be in the read mode only. Okay, so in the read mode it will be beginning of the file. In all other modes, whether it is going to be W, whether it is going to be R or R plus, or it can be W plus or plus W, whatever it is always that the file object will be pointing at the beginning of the file only. Beginning of the file only. Then what about A for the append mode? That means here the data gets appended at the end. For example, I've written hi. Let's write hi. So hi, I have to write friends here. That means whatever the string I want to write, I've already opened a file, I have written hi there. I want to add on friends word now for this already opened file. That means I have to open this file in the append mode only, not in the write mode. If you open this file in the write mode, what will happen? It is going to overwrite. Then that means what happens? This hi will not be there. It just comes as friends. It will be overwritten. If you want to add on the content for the file, what is there? That means you have to open the file in the append mode. That is very, very important. If you open in the write mode, anyway I want to write it. If you open in the write mode, it will go off. It overwrites the content that you keep in the mind. Clear? So we'll just go for the next content. That is called pickle. Okay, well, yeah, that's the topic I wanted to do. So far, you know how to store a variable in the memory? Very simple, ma'am. What is there? Just declare one variable called equal to 10. How to store this in the secondary memory? Ma'am, what I know, I can store it everywhere. Word also and Excel also. Not like that. I want to store. How do we store? See, what is this? This is basically a variable. Whether it is any kind, whether it is a list, whether it is a tuple, whether it is a dictionary, whether it is an integer, whether it is a float, whether it is a string, anything in Python will be considered as objects. Will be considered as objects. So this object, if we have to store as it is in the secondary memory, if you want to store these objects in the secondary memory, how to do it? That's what we learned. We have two files, text files and binary files. But if I store all these things in terms of text, for example, I am going to write it as L is equals to 10, 20, 30 I have written, and if I store this in the form of text, how will I be able to retrieve what is L of 0? I will not be able to retrieve because everything is in the form of text, no? I will not be able to retrieve it. Now, I want to retrieve it, a particular value here means this should be stored as an object itself without a text. I don't want to store it as a text. It has to be stored in the form of text only without reformatting the structure, without losing the structure, without losing its hierarchy. Then how to do it? We need to have a special module for that. How to store the objects in the memory, not as a text file. How to store objects as it is in the memory and retrieve it as it is as an object only without losing its structure hierarchy can be done using a technique or using a module called pickle module. So how you can do it? So pickle module basically it has two functions, dump function and load function. Using this function you will be able to do it. So let's understand now. So here there are some two terminologies we'll understand. There's something called serialization and we have a deserialization. What is serialization? Serialization basically helps in converting the Python objects into byte streams so that I can store it in the binary file. What is it? I told you. What is serialization? Serialization is a method. It's basically that's a process that helps in transforming the Python objects into byte stream, because binary files should be in terms of byte streams only, zeros and ones only. That is done a technique called, that process is called serialization. Okay, this process is called serialization, but how do we literally do it? How will I convert my Python objects into byte streams and have to store it in a binary file? To do it, there's a function called dump function. There is a function called dump function. Can I use the function just like that? Definitely not, because this function belongs to a module called pickle module. Then how do you use that function? Pickle.dump function. What are you dumping? You're dumping an object. Which object? Let's consider I'm dumping here. Okay, where I'm dumping? Into the file? No. Which file? Which file? File object. You would have written file object. Is the point clear? So what I'm trying to tell you, a pickle is basically a module that helps you to store the byte objects, store the Python objects into the memory, into the secondary memory, and helps you to retrieve it using a two process called serialization and deserialization. Serialization is also called as pickling, and deserialization is also called as an unpickling. What is serialization is done through a process called dump function, and deserialization what? Deserialization means basically it's an unpickling process. It's the reverse of pickling, I can tell you. That means what? That means it basically converts the byte streams. Whatever is there in the byte streams, I have to get back my object. Object will convert into byte stream, that will become pickling. From byte streams, I want my object back. That is called deserialization or unpickling. And how do we do it? I have to get my object back now. That means I have to load it. Load it. How will you call the function load function? Very simple. Pickle.load function. Pickle.load function. Load from where? Using object only, no? File object. And it is giving you an object only. Let's consider it as going to be a list. It returns that list. Is the point clear? That's what I was telling you. Let's go back now. So I was just telling you dump used for serializing, pickling, writing Python objects into binary file. Load used for deserialization, unpickling, and reading Python objects from the binary file. Pickle.dump object. What are you dumping? Where are you dumping? What are you dumping? Where are you dumping? Data object, file object. Next we have load function. Load function, remember, it always gives you an object. Object. Okay, I can write it as an object here. Okay, object is equal to pickle.load. It will return. You have to receive, no? If it's loading means you have to receive that, no? That's very important. Okay, let's start with the next chapter, that is stack and queue. So in this chapter, we'll be learning about the data structure. Okay, we'll be learning about the data structure, stacks and queue. So what is a stack? Stack is basically a linear data structure where elements are added or removed only from one end. Let's consider a stack of bangles. There is no bangle, of course. So what do you mean by stack here? Stack is basically a linear data structure where the elements are added or removed only from one end. If you consider a stack of bangles, I can just add the bangles or I can remove the bangles only from this end. I can't add it or remove it from this end. Isn't it as simple as that? So what is a stack? Stack is a linear data structure. A data structure is basically a method of organizing the data very efficiently. I have to store it very efficiently. I should be able to retrieve it. And it's a linear data structure. That means the elements are stored one after the other. Let's consider some elements here, and these elements are stored one after the other, wherein the insertion and deletion takes place only from one end. Only takes place from one end. That means if I have to, for example, I have just stored 10 here. On top of it, I have to add it here only. Now I have to remove it. Then 20 only will come, not the 10. Because insertion and deletion takes place only from one end. That is called stack. Is the point clear? Okay, so we have many examples also. I think it is given in the next slide, wherein you have a stack of bangles, stack of books, okay, pile of books we call it as an or stack of plates. There are plenty of examples for stack. Understand this. Okay, the end where we add or remove the elements is called as on top of the stack. What do you call it? It's called as on top of the stack. Elements, addition, adding of elements, removal of elements takes place only from one end. That end is called as on top, and we call it as LIFO. What is that principle? Stack follows a principle called LIFO. LIFO is last in, first out. And what is queue? A queue is also a linear data structure. Queue is also a linear data structure wherein the elements are inserted, okay, and removed from both the ends. Here we have two ends. Okay, let's consider that there are a queue of people standing, a queue of people, especially they want to deposit the money. Okay, they're just waiting in a queue, in a bank for depositing some money. Then that means what? Okay, there is another person. There are already 5 people standing here, okay, in the queue to deposit an amount here, okay, near the counter. So here we have the 6th person coming here. Will this person allow him to join here or here? That means they have to join only from the rear end of the queue. The rear end of the queue only will be allowed, right? Similarly, deletion will take place. If the person is done with his work, then he'll just quit from the this will be removed from the queue, right? So here deletion takes place from the front end and insertion takes place from the rear end. Queue has 2 pointers, I can tell you. That means we have 2 ends here, front end and the rear end. Is the point clear? So we have a front end and the rear end, and follows a principle called FIFO, that is first in, first out. First in, first out. The person who is standing in the first has to be addressed first. Should be get served first. There are some exceptions also, so we'll see that. So, okay, the insertion, deletion takes place from 2 different ends. We call it as queue, a simple queue. Okay. Similarly, here we call it as deck. So, what is deck? A deck is basically insertion and removing of elements. Insertion and removing of elements takes from both the end. Insertion takes place from the rear end. Insertion takes place from the rear end, from the front end. Deletion takes place from the rear end. Deletion also takes place from the front end. Both insertion, deletion takes place from both the ends. We call it as deck. So here this can be used to implement even stack as well as queue. If you restrict, out of all the 4 operations, if you restrict any 2 operations, it becomes a stack. Okay, and then here, of course, so if you implement only insertion, deletion to express the opposite ends, then it will become the queue. So if you implement a deck data structure, automatically we can have 2 other data structure, queues and stacks and queue both. That is the benefit of deck. Clear? So we'll just go for the next slide. So what do we have? So we have some real life applications. Pile of cloths in an almirah, multiple chairs in a vertical pile, bangle, own on the wrist, and box of eatables in the pantry are some of the examples. For the stack and for the queue, what are the examples they've taken? Train ticket, waiting list, customer service calls, vehicles and toll booth are these are the different examples that we have for the queue. And deck, re-entry of the ticket counter. So we can just go back to the same example. So let's consider that we have some 3 people here, they are just waiting, okay, near the counter. Okay, so this person has already taken the ticket and he has been removed from the queue. Okay, after 5 minutes he'll come, okay, and he just ensures that he wants to get his change back. Okay, he just forgot to take the change back. So is that he is going to wait? Let's consider that by the time he comes after 5 minutes, there are 10 more people standing. Will he join from the rear end, or will he be given the privilege? Will he be given the privilege to re-enter the queue from here only? Anyway, just to take the change only, we have to give him some privilege because he was already there in the queue for a long time. Okay, for example, there are so many patients waiting for a particular doctor visit, and there is some emergency patient who comes in, then we definitely have to allow him, right? So there are certain exceptions. Okay, there are certain exceptions, certain emergency cases we have to let the person to re-enter the ticket counter in this case. Okay, So that means insertion has to be from the rear end only in case of a queue. But in emergency, we have to let the person to join the queue from the front end also. That becomes deck. That becomes deck. Okay, and similarly, toll booth queue redirection. Toll booth redirection means what? Let's consider there is a particular toll booth 1 and there is another toll booth here. Okay, all the vehicles got stuck up here and there is no vehicle only. There are some 3 vehicles standing here. There is no vehicle only standing here. Okay, the system got stuck up here. So now this car can come here and can join this particular toll booth. Deletion is taken from the rear end, not the front end. Deletion is taking from the rear end, and of course insertion is taking place from the rear end only. This is one. Again he'll join and he'll join here, not here. Getting my point? So what I'm trying to tell you is, here you're trying to, this is the first car, this is the second car, and this is the third chance for him. But now we are deleting from the rear end only. Usually deletion takes place from the front end. No, deletion is taking place from the rear end only here. That becomes stack. Is the point clear? So we'll just see the computer science application. Reversing a string, undo, redo in editors, web browsing history, parenthesis matching are some of the examples for stack. And queue we have web server requests, multitasking, operating system print. Okay, when you're giving print and all, it basically follows the queue principle. And browser history, navigation, undo, redo in text editors, palindrome checking. We'll just go in detail with the palindrome checking using deck now. Clear? So we'll go for the next slide. So what is there? See, there are a number of operations on the linear data structure, especially the stacks and queues. So what is stack? It's basically a linear data structure that follows the principle called what? What is this? Stack of bangles, don't think something else. Okay, it's going to be a stack of bangles here. So what are the different operations that are allowed here? Adding an element to the stack, removing an element from the stack. So adding an element to the stack is called as push operation. Okay, let's consider that we have a stack here. Okay, 10, 20, 30. Can I add one more element? Space. If the space is only 3, I have already allocated. Can I add 40 here? Can I add 50 here? Can I add 60 here? Definitely you cannot add it because there is no space. Check the space and then you enter the element. No. Check for the space and then enter the element. That is called overflow condition. Checking whether the stack is full or not. If the stack is full, you say the stack is full. Okay, definitely you are giving a clear-cut message. Okay, when the stack is full, it becomes an overflow condition. Okay, check the overflow condition and then you insert the element. Inserting an element to the stack is called push operation. Okay, and whereas in case of pop operation, there should be some elements for you to delete it. For an empty stack, you cannot delete it. From an empty stack, you cannot remove an element. Empty stack indicates an underflow condition. Empty stack indicates an underflow condition. Whenever we are doing a pop operation, we are checking an underflow condition at the is empty, we call it. We call it an is empty function. Is the point here? Is empty we are checking, and based on that only we will be able to remove the elements. If there is no element in the stack, how can you remove it? Remember, push, you have to check the overflow condition in all of the programming languages, not Python. Python gives you a lot of chances, there is a lot of features, lot of chances, no, not that exact word, lot of features wherein, you can, there is no end only. There is no end. You can keep inserting as long as the memory is there, you can keep inserting the elements. There is no need to check the overflow condition in Python. In general, for other languages, definitely you have to check the overflow condition. Underflow, definitely you have to check even in Python also. If there is no element, how can you remove an element irrespective of the language, right? So next we'll go for the queue operation. What is queue? Queue is basically adding or removing an element takes place from two different ends. And it follows a principle called what? FIFO, that is first in, first out. That is called first in, first out. What are the different operations of queue? We have NQ, DQ, is empty, peak, is full. NQ is what? Inserting an element from the rear end of the queue is called NQ operation. Deleting an element from the front end of the queue is called as DQ operation. Okay, in case of an NQ, definitely you have to check in underflow condition, it is the same thing. Underflow means if the Q is empty, how can you remove an element? And if the Q is full, how can you insert an element to the Q? Overflow condition, it is the same only. Next, what we have E is empty. Check if the Q is empty or not. If the Q is empty, then definitely before performing DQ, we're going to check the E is empty. Okay, check if the Q is empty or not. A special condition only has been given to check for the underflow condition, nothing but an underflow condition only. Clear? Similarly, we have a peak that gives you the front item without removing. Similarly, we have an isempty, peak function. All these things are there even in the stack function as well. Stack operation also we can include this peak and isempty also we can have it. It is not there in the textbook, but still you can write it. That's not wrong. Okay, it's going to give you the front item. It is going to give you, for example, so this gives you the 30 as the peak element in case of stack. So if I write 10, 20 and 30 in case of Q, 10 will be given as the topmost element, I can tell you. That is there in the front. Q is full. E is full means what? When the Q is full, okay, it's basically not required in the Python based Q. Python based Q, there is no something as overflow condition, because there is a feature for you to keep entering the elements as many as elements you want. There is no restriction as long as the memory is supporting for you, right? Similarly, we have a deck where insertion can be taken place from both the ends, rear as well as front. Insert front, insert rear, delete front, delete rear. Okay, it is all the same. Okay, similarly, we'll just have to see the implementation part. Means it's very simple. Okay, it is almost the same in all these data structure. Little bit variation only is there. That is what you have to observe here. What is it? Glass stack is equals to list. Empty stack you're going to have it. Okay, and similarly, I'm going to check E is empty. E is empty is basically going to check whether the stack is empty or not. Stack is empty or not. How are you going to check? Okay, def is empty, glass stack. Return length of glass stack. If the length of the stack is going to be 0, definitely it is going to be an empty stack only, no? I can write it, return 0. Return length of glass stack equal to 0. If length of glass stack equal to 0, you return that. That means 1. It's going to return. If this is true, it is going to return 1. It's going to return 1. Else part you have to take it there. Or else you can write it like this. You can write it like this. You can write like this, or you can write it this like this. That means if len of my stack equal to 0, return true, else return false. Clear? Size. Def size of glass stack, it is all the user defined functions. Using user defined functions only they have implemented it. So return len of glass stack, that gives you the length of the glass stack. So inserts an element. Okay, def push operation. Push operation is to insert an element to the stack. Insert an element to the stack, basically you need the glass stack, which is nothing but a list only, and the element to be inserted. How do you insert an element? There is an element 10 here and there is an 20 here, and for this list, so this list can also be considered like this, no? How will I insert 30 or 40 here? Just append it. Like is a function called append function that comes in list glass stack dot append element. Okay, and similarly we have to remove the element. For you to remove an element, that means to say that you're going to check the underflow condition. E is empty, you have to check. If E is empty, glass stack, underflow, return none, nothing you have to return. Return none. Okay, underflow, return none, else you're going to pop the element. You're going to remove it. You're going to remove that, to delete it. Clear? Similarly, we have to display it. So I'm going to check current elements are there in the stack area, and you have to repeatedly display. No, you can have some 10 elements, 20 elements, 3 elements. You need to have a loop for you to display. So for I in range glass stack -1. Okay, from here till here, this is going to be the len -1. So this is going to be 0, 1, 2, right? So total elements is 3, len -1. Okay, length of glass stack -1, -1, -1, because you have to go in the reverse direction. How will you see? Will you display as 10, 20, 30 or 30, 20, 10? How do you retrieve it? Topmost element will come, right? Topmost 30 will come, 20 will come, 10 will come. Similarly, from minus 1, 30 will come, again I'll decrement, 20 will come, again I'll decrement, 10 will come. As long as there is element in the stack, it will keep displaying all the elements. That is why they are given in the length of class stack. Every time it keep decreasing it. Okay, and print the class stack of I. Clear? Similarly, we have a queue here. It's similar only. We have a list only. We are considering even for the queue also. Is empty is as it is. Length is also same. But instead of queue, instead of stack, we have just used queue here. Because queue stack is implemented in the form of list only. But how does it make a difference? Insertion deletion is implemented in a different way. Let's try to understand now. How is it different? So you can just see here, NQ, myQ element, you're going to append it. So I'm going to take 10, 20, 30 and I want to insert an element. Here also it is append, it is the same thing only, not much difference here. While popping, which one you're going to pop it? You're going to pop 10 or 30. That means 10 should be removed. No, the person who is standing in the first should be served first. That means this should be removed. How do you remove this? This means what? Always this. If I remove this. That means the first element in the queue always. How do you represent the first element in the queue always? That means it will always have the index 0. Always it will have the index 0. That means return myq.pop of 0. You can give the index and remove it. If you don't give the index, always the last element will be removed. If I don't give the index, if I don't give the element, the last element will be removed here. Always the last element will be removed. If I give the index, the first element, whatever the index are given, that element gets deleted. That's the difference, main difference. Else, queue is empty. Clear? So we'll go for the deck here. It is also same as queue implementation. Inserts an element. It is same as NQ. This is also going to be same, not much difference because insertion at the rear end, deletion from the rear end will be the same only as queue. Okay, and then we'll go for this part. So I just want to print the top of the class stack, the topmost element. For example, 10, 20, 30 is there. I just have to print the topmost, the peak element I have to display without deleting it. Then how we are doing it? Check whether there is an empty or not. Stack is empty or not. If there is an empty stack, then you have to say stack is empty, none. Or else, just display this one. 10, 20, 30. How will I get this? This is L. Okay, this is L. L of minus 1 means what? This is the index 0, 1, 2, forward indexing. Minus 1, minus 2, minus 3. This is going to be the backward indexing. Just give us minus 1, no, done with that. It's just displaying only, not removing. Don't use pop here. Don't use pop. Pop means it will be removed. Yeah? Okay, similarly we have this one. So how will you just display the topmost element in the queue? That means I'll go for my queue of 0. In case of 10, 20, 30, I want the topmost element. In this I showed you like this because it is easy for you to understand in terms of list. But this I'm showing you as it is. I want the topmost element from the queue. This I want. This means what? 0 only, no. List of 0. Instead of list, I'm taking it as queue of 0. Clear? That's it. Okay, so we'll go for the get front. Get front is also same only. No much difference. Deck, instead of queue, I'm just using deck here. Instead of queue, I'm just using deck here. Okay? And here we have get rare. So get rare, you have to understand that rare element I want. How will I get this? Deck of minus 1. I can get deck of minus 1. Deck of minus 1. Just take it as my deck of minus 1. No, that's more than enough. Right? Else, deck is empty. Okay? And similarly, we have a deletion from the rear end. In case of deletion from the rear end, how do you do it? Very simple, pop. Very simple, pop. Pop will always give you the last element. Okay? Similarly, I want to insert from the front end. I want to insert the element from the front end. Means you can make use of a function called insert function. Insert function 0, element. Insert the element 20. Insert the element 100. Here only means what? give the index, insert 100 here. Insert. Up and if you use, it will come here, 40 will be coming here. But wherever according to your requirement, if you want to insert, you can make a function called insert function only, which takes index as well as the element to get inserted. Clear? So we'll just go for the next topic. That's called notations for the arithmetic expressions. Okay, let's start. Okay, let's come for the notations for the arithmetic expressions. So in this we have an expression here. I think you already know an expression, a simple expression, x plus y. What is an expression? A combination of operands in the operator when evaluated results in a single value. What is an expression? Expression is a combination of operators and operands when evaluated, it results in a single value. Right? That is what an expression is. So what are the different kinds of expression we can have it? That's what they are telling. We can have an infix expression, a prefix expression, and a postfix expression. If the operator is in between the operands, we call it as an infix expression, it is in between. If it is before the operand, we call it as an prefix expression. If the operator is after the operand, we call it as an postfix expression. The operator can be anything, don't worry about it. So this prefix expression is also called as Polish notation, and this postfix expression is also known as reverse Polish notation. So here, why do we have to go for prefix expression or postfix expression when we have an infix expression? Say very simple example, if I take it as an x plus y and then like z plus 8. So we have an expression like this. So you have so many operator, plus is there, and then we have, I'll take this also, a multiplication is there, division is there, parenthesis is there. Which one to execute when? What is the priority? So now our task is not for us to execute, because we know the BODMAS rule, everything we know it, we have to execute it. We have to make the computer to execute, we have to get the result very quickly. That is the major intention. So in order to remember all the precedences, so okay, I have to execute first and then do it, and then you divided it. So instead of doing this using an infix expression, if it is converted into prefix or the postfix notation, then it is easy for the interpreter or the compiler to give the results in a much easier way when compared, easier way and faster way when compared to that of an infix expression. This can be evaluated using stack applications only. These are basically the applications of stack only. Is the point clear? So we'll just go now. I hope you know the need of the other expressions like in prefix and then postfix expression. So what do we have? So we have an algorithm to convert infix to postfix expression. Okay, so consider this expression only. We had this x plus y. Okay, similarly we have z plus 8, something like this we'll consider. We have an infix only. Okay, it is in between the operands only. Now how we have to convert this means any infix expression, it has a certain characters in that. Infix, this is an infix expression, this has to be converted into postfix expression. If I give x plus y means, how will you write as a postfix expression? That means I am going to write it, the operator after the operand. That is what you mean by postfix expression, right? That is what you mean by postfix expression. Now what we have to do, so in order to convert an infix to postfix, what all the terms you may get it? You may get a parenthesis, left parenthesis, right parenthesis, operator you may get it, or you may get an operand. These are the possibilities that you may get in any infix expression. Left parenthesis, right parenthesis, then we have an operand, operator, then we have, I think I've covered everything, right? These are characters that you may come across. So if you get any of these characters, what are you supposed to do? in order to convert infix to postfix. See, if a simple expression I can do it manually only. Okay, if it's for a complex expression, then I have to use an algorithm. Anyway, we have to automate the task. No, ultimate intention is like we don't want to sit for hours together and to calculate and to convert and all. So we have to do it, like automatically. We want the system to do it. So for that we have an algorithm. So let's understand what is that algorithm to convert. How do we convert infix to postfix? So here, what they have done. Okay, if you have, see, this is basically converting infix to postfix, or whether we have to evaluate a postfix expression. It is not postfix to infix. It is basically to evaluate a postfix expression. Evaluate a postfix expression, not postfix to infix. So in order to convert infix to postfix, we have left parenthesis, right parenthesis, operator and operand. What you have to do, if you have a left parenthesis, just insert to the stack. Insert to the stack. Stack is a linear data structure that follows the principle called LIFO. That means last in, first out. Okay, so here we have push to the stack. If you have right parenthesis, keep on popping the elements till you get the left parenthesis and discard both the parentheses. And if you get an operand, just append to the postfix expression. Ultimately, we have to get one postfix expression. No, we need to get one postfix expression only, right? So similarly, what I have to get? I have to get xy plus here and then z8 plus here, and then I have, this is there, this is A, this is B, let's consider xy plus z8 plus and then slash. This is what the final expression we have to get. I have done separately for this, You consider this as A, this expression is B. A by B is what? AB dash. That is what I have done. Manually I have done it. This we have to convert into the postfix using the algorithm now. So this is clear. Left means push to the stack. Right means keep on popping the elements till you get the left parenthesis and discard both. In case of operand, you append to the postfix expression. Final expression is this only, postfix expression. It is basically a string only. And if you get an operator is the main important thing that you have to keep in mind. If you get an operator, what you have to do? Operator means, if you get an operator, there are two possibilities. If the operator is having a higher precedence, than the stack operator, you're going to push to the stack. Pushing is what? Inserting the character to the stack. And if the operator is having a lesser precedence or equal to precedence of the stack operator, then you have to keep on popping the elements till that operator gets higher precedence than the stack operator. Then you can push that. Alright, I told you the operator. What if I get an operator? That's the question. Operator is having a higher precedence, then you push to the stack blindly. No need to worry. If the operator is having a lesser precedence or equal to precedence of that of the stack operator, then you have to keep on popping till that operator is having a higher precedence than the stack operator. Then what is it? Still confused? We'll look at the example. We'll come back to this later. Okay, this is the example they've taken, the same example only. So what we have to do? So I have to start from the left to right. So what is there? Parenthesis is there. Parenthesis means what? Very simple, push to the stack. Parenthesis, I have encountered a symbol called parenthesis. What is the action I have to do? I have to push to the stack. So this is the representation of stack. I have pushed to the stack. And this is going to be the postfix expression. Nothing is there. It is empty now. Next character is what? It is going to be the x. X is an operand. Operand means what? You need to append to the stack. X, append the string to the stack. Then we have same only, nothing is being stored in the stack. Then x, nothing extra added to the stack I meant. Then we have plus. Plus is an operator. Operator means check the precedence. Operator means check for the precedence. Check for the precedence. Of course, it is a Bodmer's rule only. Okay, first thing it's going to consider multiplication, division is going to be the first place your priority. Plus minus will be there, and of course we have okay, this parenthesis, left parenthesis having the least precedence. Now we will come, plus is there. What is parenthesis? It is having a least precedence. That means plus is having more precedence, you push to the stack. I've pushed to the stack. It's still x only. Next, what we have y here. Y means it's an operand. Append to the stack, append to the postfix expression, xy is there. Okay, next what we have, I'll just rewrite the expression. What is that expression? X plus y z star 8. This is what the expression. Okay, this is what the expression. And similarly, we have right parenthesis. Right parenthesis means keep on popping till you get the left parenthesis. See, what we had here is just pluses there. So keep on popping everything till you get the left parent, discard both. Pop this, discard. Pop this, discard means nothing is there in the stack, right? It's empty. Okay, and when I pop it, what I have to do? I have to add it to the postfix expression. It is xy plus, I discarded the parenthesis, remember. Then we have got the slash. Slash is there, check the precedence. Nothing is there. Add to the stack. It's having its own precedence, nothing for me to compare. You push to the stack. Then we have this left parenthesis, so push to the stack. No need to compare. Then you have z is there, then you have to append to the operand. Okay, append to the postfix expression. Then we have star. Star is there, then we have left parenthesis, parenthesis having a least precedence, just push to the stack. So just push to the stack. 8 is there. 8 is means character, operand. Then I am going to add it to the postfix expression. Then we have right parenthesis. Keep on popping till you get the left parenthesis. Okay, I have to pop this, I have to pop this. That means after popping, I have to, star is there. See, Z8 was there. I have appended this, I have discarded this, discarded both. Then what we have next? I have nothing. I have nothing. Just, okay, remove all the elements from the stack and add it to the postfix expression. That is what we got. Clear? Okay. Next what we have is going to be evaluation of postfix expression. Evaluation of postfix expression is what? In this case, okay, what we have, very simple, you have to know here, given an postfix expression, how will you find out the value? Expression is basically a combination of operands and operators when evaluated results in a single value. Similarly here, I can have an operand, operator, but not the parenthesis. You will not find the parenthesis. Operand means you need to push to the stack. Operand means you need to push to the stack. Operator means you need to pop to operands. Operand means you need to push to the stack. Operator means you need to pop two elements from the stack, perform the operation, and then again you push the result back to the stack. Is the point clear? Add one item in the stack and results, or else if there is only one element, that will be the result, or else it is going to be the invalid expression. I'll just show you with an example, you'll be able to understand in a better way. Okay, so let's take an example here. We have a postfix expression. What all we can have in the postfix expression? I can have an operand and an operator, but not the parenthesis. Parenthesis is not here. If you get an operand, what you have to do, just push to the stack. If you get an operator, then pop two elements from the stack, perform the operation, and then push the result back to the stack. Okay, we'll just do it. 7, 8, 2 is there, 7 is there, push to the stack, 8 is there, push to the stack, 2, all are operands only. Operand, no doubt, push to the stack. 2, 8, 7 we got. Then we have star here. When you get an operator, just pop the element. Just pop the element. That means what? We have 2 being popped out. I'm going to pop it. I'll store it as N2. Remember, you have to store it in a variable called N2. Is it N2? Any variable, but it should be considered as a second variable when you're performing an operation. And this will be stored in N1. This is not there in the algorithm. It is easy for you to understand. That's why I'm writing. Perform the operation now. N1 star N2. That means what? 8 star 2. 16 we got. So you got the result and then you push to the stack again. So push to the stack again, 16 and 7 I've got. Next is what? So it is 4 is there, so 4, 16, 7, then you have got operator, then you pop it. This is N2, this is N2 and this is N1. So N2 is equals to 4, N1 is equals to 16. Perform the operation N1 slash N2, this is important. 16 slash 4, it is not the other way. That's why it is important, I told. So now what we have got the answer, it is 4. You push the result back to the stack. So we have got 4 and 7. Next what we have, it is pluses there, perform the operation. That means this is N2, this is N1. So that means what? 4 plus 7. Sorry, 7 plus 4. Anyway, it doesn't make a difference here. It's 11. Then you have to push it back to the stack. But nothing else is there. You have to pop it again. Only one value I've got. No other value also here for me to perform further operation. Only one value. Then definitely what is the answer? We have 11 is the final answer that we have got. Is the point clear? It's going to be 11. Okay, and similarly we have a palindrome algorithm here. So what is a palindrome algorithm? So what we have discussed so far is going to be an applications on stack, whether it is going to be an postfix expression, whether it is a postfix expression or whether it is going to be in terms of postfix expression, or whether it is going to be infix to postfix, or it is a evaluation of a postfix expression. It's basically an application of stack only. Okay, and now we'll learn the application of TAC also. Okay, so what is an application of TAC? Very simple. To check the palindrome, let's consider a string called madam. I've taken a madam. So if you reverse also, I'll be able to read it as madam only. Okay, if I read it in the forward direction or in the reverse direction, it is being read as madam only. Similarly, you can consider as radar, okay, level, whatever the Malayalam. Okay, there are so many palindrome strings, no? So I have to check whether the given string is palindrome or not. Palindrome is basically a string. If you read it in the reverse direction also, it should give the same word. Right, that is what you mean by palindrome here. So now what we have, so I have taken a string here called the madam, and this madam has to be stored in the deck. It has to be stored in the deck. Very simple. How do you do it? Traverse the string, each character by character you traverse. To take each character by character at a time, make use of a for loop and take each character by character and start inserting the character at the insert rare. Deck only, make use of insert rare and then keep on inserting. That means I have inserted M and then D, and then inserting rare means at the rare end only we keep inserting. No, M is done and after that A, D, then A, then I have done M. Okay, I have done this part now. Then after storing the entire string using deck, using one of the functions of deck called as insert rare, I have stored the entire string in the deck data structure. After that what we will do, okay, so let's consider madam has already been inserted, we'll consider. After doing that, you have to remove one character each from the front and the rear. I have to remove this, deletion from the rear end, deletion from the rear front end, deletion from the rear end, deletion from the rear end. From both the end at a time, one character has to be removed. Delete rear means I'll give M, delete front means I'll get M, compare it, then only palindrome will be satisfied, right? So if you remove it, okay, using these two functions, delete front and delete rear. So if you check, see M I've got, if it matches, then you continue with the loop. Okay, I've removed it, yes it is true, then I'll continue with that. Then I'll get A here, delete front, delete rear element. Again I'm going to check it, is it same or not? So I keep on doing this process till see here, until deck is empty, for even number of characters or for the odd number of characters in this case, wherein I have only left with a single character. The single character. If you have, for example, let's consider that I have some 6-letter word, then I will not be left with any other character, right? So deck can be an empty if it matches with all the characters are same only, everything is matching, is matching, AA is matching, or it's just left with one character. That means to say that string is a palindrome. String is a palindrome. If not, no. If not means you can just say that string is not palindrome. As simple as that. Clear? Okay, let's start with the next chapter, that's called sorting. So I think you'll be knowing what is sorting. Sorting is basically arrangement of elements either in ascending order or descending order is called as sorting. Okay, sorting can definitely be applied, especially in terms of what? For the numeric values, even for the characters, for the numeric, and even for the strings we can use this. Even for the strings also, let's especially for arrangement of the names in alphabetical order also we can use it, that you already know. Okay, so for smaller set of data, definitely the sorting technique will not be that significant, I can tell you. Okay, that means whatever the amount of time that we invest for sorting, okay, it's not that significant for a smaller set of data values. For a huge amount of data value, for a huge data set, definitely this extra time that is required for sorting the elements is really worth to take that overhead in order to sort the elements, so that the accessing, the retrieving of the elements can be done easily. Let's consider a dictionary. Okay, I just want to consider a dictionary and you want to find out a particular word. Let's consider that I want to find out the meaning of zoology. Something I want to search. So you want to search, let's consider I want to find out the difference between enthusiasm and excitement. So what is the difference? So something like that if you want to find out, means if it is not arranged, it is very difficult, right? It is very difficult. So that's why for a huge data set, considering an algorithm, considering the different algorithms is very, very important. Keep that in the larger data set. Since we cannot take for a larger set and explain here, okay, for the understanding sake, we will just take some little elements, some few elements, and then try to explain. Keep that in the mind. These sorting techniques are basically made for a huge data set. Okay, so there are different algorithm that is there for the sorting techniques. What are the different sorting methods? We have a bubble sort, we have a selection sort, and we have an insertion sort. Okay, so we'll just so we'll just start with the algorithm now, that's called the bubble sort. So in case of bubble sort, what exactly a bubble sort means? Let's consider I'm going to take a heavy object and I'm going to throw into the water. So if I throw it into the water, it's going to make a kind of a bubble sound, right? So that is what they've taken this bubble meaning. So let's take the elements here as 5, 4, 3, 2, 1 and consider whether it is going to be, let's have an, keep that in the mind that a bubble sort and selection sort and insertion sort is basically done for the ascending order. Okay, I've just taken in reverse direction so that I can show you how the elements can be arranged in an ascending order. Okay, I've just taken an example. This has to be arranged in the ascending order. So bubble sort is what? When you throw a heavy object into the water, it makes some bubble sound, right? So even here also in case of bubble sort, what we are doing, I'm just taking the heavy object. Ma'am, what do you mean by heavy object in terms of number? We can't take heavy object. So here we'll take is the largest element. Heavy means what? So that you'll be able to relate the context with which I'm trying to tell you is you can relate it. The large, you cannot forget. See, the important thing is you need to remember the concept, logic, so that you'll be able to write the code. You cannot by heart every code, right? You need to remember the logic behind that so that you'll be able to relate it, you'll be able to recall it, grasp it at any point of time. So bubble sort is what? I'm going to consider the largest element, find the largest element and place it at the end in case of ascending order. Okay, that's why the name they've kept is bubble sort, by the name. Any sorting technique, you have to remember that any sorting technique will take two loops, one comparison and one swapping technique. So here we'll just see here. So I'm going to consider a loop here as I loop and then J loop, comparison is there and swapping technique is there. Very simple if I have to tell you like that. What? First loop, there will be a first loop, there will be a second loop, and there will be a comparison and there will be a swapping technique. In all these three algorithms, in order for you to remember, I'm just taking some simple tips for you to remember all these algorithms. What is the first loop? First loop is always will be from 0 to n only. In all of the techniques is going to be from 0 to n. The second loop is going to be starting from 0 to n minus I minus 1. Let us see an example here. So in this case, I'm going to consider the first loop I equal to 0 here. And what is the maximum value? Maximum value should be what? I should be less than 5. Because 5 elements is there, no? It should be less than 5. In case of J loop, what we have to consider? J should be equal to what? It is considered 0 only. And the maximum value of J in this case is what? Is n minus I minus 1. That means what? 5 minus 0 minus 1. That means 5 minus 1 is what? 4. It should be less than 4. It should be less than 4. Let us keep this in the mind. So we have 5, 4, 3, 2, 1 now. I'll start comparing the elements. See, anything students, what do? If I have to sort it, I have to compare it. After I compare, I swap the elements. That is what is there in any sorting techniques. Either comparing, either swapping, or I will shift the elements. So we'll just check here. So in this case, I'm going to consider what? 0 is there. I is less than n. I told you I is less than n. It's a loop. I have to repeat this. That's why it is repeating steps. 3 to 8 is being repeated. And here I've taken the second loop, that is going to be j equal to 0 to n minus I minus 1. Why less? We will understand in the steps. Okay, I'll compare these two elements. After comparing these two elements, then it is for sure that I see you have to compare L of j. L of j, see, it is num is there, num list is there, or L is there. Num list or list is one and the same variable. Okay, you can take list also. L of j is compared with L of j plus 1. 5 and 4 is there. This is going to be my j. This is going to be j plus 1. The index is 0. This is going to be 1. Let's consider. For time being, I'm just telling only 2 elements. It can be multiple elements also. So this is j plus 1. I'm comparing 5 and 4. If this element is greater, okay, if this, sorry, which element is greater? If j is greater, this element is greater, then we swap it, no? We swap it, right? That is what we are doing. I compare these two elements. Definitely this is 0. This is the index is 0, 1, 2, 3, 4. 0 and j plus 1. Okay, j with j plus 1, 0 and 1 is compared. Elements stored in the index 0 is 1 is compared. We'll swap it. It is 4, 5, 3, 2, 1. Next, I'm going to compare with j equal to 1. I have to do till 4. Remember that I have to do till 4. Then what do? I'm comparing these two. It should be what? 4, 3, 5, 2, 1. Clear? Then j is equals to 2. J is equals to 2. That means 0, 1, 2. So 2 is compared with 2 plus 1. J plus 1. That means what? It will be changing it to 4, 3, 2, 5, 1. Then I'll compare with j equals to 3 now. That means what? This 2 will be compared 4, 3, 2, 1, 5. It will be swapped. Is the point clear? Is the point clear? Remember here, the largest element is being placed. It will be identified. It will be bubbled up means what? It will be identified and it will be placed in its corresponding position, largest element. So when a heavy object is thrown into the water, the largest element, okay, the bubble is shown here, the largest element is shown and it will be placed in the corresponding position. We have done with the first iteration, done with the I equals to 0. Then we have to take I equals to 1 now. I equals to 1, what is j? J again have to start from 0 only. And here in this case, n minus, that means what? 5 minus 1 minus 1, that is 5 minus 2. That means it is 3. So that means j should be less than 3. J should be less than, see, I am starting from 0. So what are the elements? 4, 3, 2, 1, 5. Start from 0 only, compare these two elements. Swap it. 4 is greater than 3. No, swap it. It is 3, 4, 2, 1, 5. Then again make it j equals to 1. From these two you compare, swap it. 4 is greater than 2, you swap it. 3, 2, 4, 1, 5. Then j equals to 2. I have to do till j is less than 3. Not for 3, less than 3. That means only till 2 I have to take. Then what I am going to do? I am going to take it as these two. Okay. So 3, is it right what I have done? So 4, 2, okay, I have done it. So 3, 2, 4, sorry, 1, 4, 5. I will not continue because if I continue, this does not satisfy the condition. You can understand the last two elements are sorted. That's why it is n minus I minus 1. In every iteration, one element will be sorted. Need not have to go till n. For you to do this, I need not have to go for till 5 because every time one iteration is done, one element is getting sorted. N minus I minus 1. 1 less than that one comparison, I comparison. 1 element means 1 element sorted. 2 comparison means 2 elements sorted. 3 comparison means 3 iteration means 3 elements sorted. That's why it is n minus I minus 1. Got the point? Remember that. And similarly, I can just do for the next iteration also. I equal to 2 and j equals to what? J equals to 0. That means 5 minus 2 minus 1. 5 minus 3 is what? It is 2 only. So j should be less than 2. It should be 0 and 1 only. We'll consider 3, 2, 1, 4, 5. That means 3, 2 is compared. Swap it. 3 is greater than 2. See, if j is greater, if this is greater, then I have to swap it. No, this is greater. So 2, 3, 1, 4, 5. Again for j equals to 1. These two has to be 1 and j plus 1. That means this 2, 1, 3, 4, 5. Is the point clear? That's it. I should not continue. It should be less than 2. Similarly, so first 3 elements sorted. So similarly, I have I equal to 3. And what is this? 5 minus 3 minus 2. That means 5 minus 5. Sorry. 5 minus 3 minus 1. That means 5 minus 4, 1. J should be less than 1. J should be less than 1. What is the value of 0? So is it 0 less than 1? Definitely 0 is less than 1. You execute this. That means 2, 1 is compared. You swap it. It is, okay, I am just writing here. So it is done. Again for the next iteration, does not satisfy the condition only, it comes out of the loop. Is the point here? Bubble sort means bubbling it out the largest element at the end. Clear? We'll just go for the next one. Okay, we'll go for the selection sort. What is selection sort? We'll try to understand. I'm going to take the same example. You'll be able to understand in a better way. So in case of selection sort, how do we do it? See, 5, 4, 3, 2, 1 I'm going to consider. And what are the loops I needed? Let me write it here also so that it becomes easy for you. What is the first loop? What is the second loop? What is the comparison? And what is going to be the swapping technique? First loop, I told you it is going to be from 0 to n for I. What is the j is what? J will be 1 greater than element. That means I plus 1 till n to n. And I'll compare L of j. Remember here, I let me write this part later. I will tell you what is the logic for the selection sort. What is the logic for the selection sort? Basically here we are going to identify, select the smallest element. I want to select the smallest element. I don't know which is the smallest element. Until I compare all the elements, I don't know which is the smallest element. Let's assume this element is the smallest element, and I'm not going to store the smallest element. I'll consider this first element place itself is containing the smallest element. That means what is this m they have taken? It is the index. The first element is containing the smallest. First index is containing the smallest element. That is what we are thinking. We are assuming now. In this entire selection sort is basically divided into sorted list and unsorted list we are considering. And where is sorted? Everything unsorted only. Yes, everything is unsorted only. So right now everything is unsorted. So whatever the element that comes this side will be, whenever we keep comparing, it becomes sorted elements. Sorted list, unsorted list. What I'll do, I'll find out the minimum element or the smallest element, and then I keep on swapping the elements. We'll understand now how to do it. So what I do, I'll take 5, I'll take, this is going to be the smallest index, okay, the index having the smallest element, and then what do I do, in case of this I is equals to 0 only, and definitely I should be less than 5, this is the normal case only, and j I am going to consider as what, I plus 1, that means what, it is 1, and j also should be less than 5 every time. Okay, and you don't have to worry about it because it is always here. You can just consider here also. Okay, it is less than n only. Why? We will see. How? Also we will see now. What I'll do? Take the first element. Okay, take the first index. That itself is the smallest element index I'm considering. And after that, I'm going to compare with L of this. L of j is what? It is going to be 1. This I'm comparing with the smallest. Element only comparing. M is going to be the minimum. See, M means is going to be the minimum. Okay, is the minimum index, I can tell you. Element of that means L of M. I'm comparing with L of J. L of min is compared with L of J. Compare it. Is 4 less than 5? Definitely it is less. Then this I am telling as going to be the minimum index. This element is the minimum element I am considering. I change it. Okay, what is the flag? Whenever I change my minimum element, I will set my flag also. To indicate that wherever I have changed the minimum, if there is no change, I will not make the swapping technique. So what will I make? I am just going to make flag is equals to initially 0, and I have changed here. See, I have changed my minimum. See, now 4 is less than 5. 4 is less than 5 means minimum has become 4 now. The index has become what? The index has become 0, 1, 2, 3, 4. The index is 1 now. What is the minimum element? Minimum element, if I have to tell you, minimum only I am going to take it. Minimum is going to be 1 now. Index only they have taken. And after that, what I will do, I am just going for the next iteration, j equals to 2. Every time you compare with the minimum, not with anything else. Minimum only you have to compare, minimum with L of j. So what is 2? 2 is compared with this. Now this is going to be the minimum. Okay, so I take again 4, this 2, 1. This is going to be the minimum index. Compare with this. Now 3 is the minimum. No, now 3 is the minimum. Okay, I'll make this is the minimum now. Okay, then again flag is set. Okay, flag is set. Flag is there also, flag was set. Minimum is 2 now. Okay, and j equals to 3. So 5, 4, 3, 2, 1. I've compared with 3 and 2. And again this has become the minimum. Flag is 1 and minimum is 0, 1, 2, 3. The index where it is been having a less element. Index is 3, element is 2. Again, I'm going to take till 4 because I can go till 4. That is what it says. 5, 4, 3, 2, 1. Compare with this. This will be the minimum. And what is the flag? Flag is set to 1. What is the minimum element? Minimum element is equals to 4. Again, I'll go. So j equals to 5 does not satisfy the condition, comes out of the loop. When I comes out of the loop, what I'm trying to find here in the selection sort, I'm trying to find the minimum element by the index. Store the index. Minimum element only I'm trying to find, but store the index. Whenever I've changed the minimum value, then I have to ensure that I've changed it by making a status variable flag being set to 1. Now what we will do, we will swap it. I've got them out, I've compared with all the elements. That minimum element is what? 5 was the minimum element I had compared, and I've compared with 4, 3, 2, 1, everything I've compared. Now after all these things, I've got the minimum element after all this comparison. What is the minimum element? Minimum element is going to be the 1. Element is 1. Where I have to place that? I have to place in its corresponding position. Smallest element, where do you find it? You're going to place it here only, no? That means this has to be swapped. This has to be swapped. So, when I'm going to swap it, when flag is 1 only, I will swap it. With what? Whatever the element is present in 4, you swap with what? L of I. L of I is 0 because this L of 0 is swapped with L of 4. L of 4, L of 0, you swap it. That means what? 1, 4, 3, 2, 5. This is what I've got. This is what I've got. Clear? Now what we will do, again we'll go with this. I equals to 1 now. I should be less than 5. And what is the value of j? J should always be I plus 1. J is always I plus 1. That means what? That means this is sorted. I will not take it because the smallest element has already been sorted. You just start from the next one. Sorted, then you go for the next one. It is I plus 1. That is from 2 till where I have to do? Definitely j till less than 5. Less than n, no? That is what we are doing. Now what you have to do? Again it is the same thing. Consider, make an assumption this itself is the minimum element. Minimum element. You compare with this now. Then 3 will be the minimum element. 3 will be the minimum element. Right? 1 minute. I'm going to erase this part. Okay, I'm going to erase this part. So I'm going to set flag and this is going to be the minimum. So I have to change it now. I have to change it. Right? So for j equals to 1, 1, 4, 3, this will be the minimum, and I have to change flag equals to 1. And what is the minimum? Minimum will be 0, 1, 2, 3, 2. Position, remember min is always an index. Min is always an index. 2 is the 0, 1, 2 is the index, and flag is set to 1. F means it's the flag. Because I've made the changes to the min, it's been set to 1. Now what will I do? I'm going to make it as what? I'm going to make it j equal to 3 now. 3 now. And this is being 0, 1, 2, 3. Compare with this. 3, 2 I'm comparing. Definitely 2 is less only, no? Again you change it. 1, 4, 3, 2. This is going to be the minimum. And this is 5. Definitely flag is set. And minimum is not now 2. It is going to be 3. Here. Understood? Now what will I do? It is equals to 4 now. Okay, this is for this is for this. I'm going to write it here. 1, 4, 3, 2. Okay, I've compared with this. I'll compare with this. Will I change my min? 2 and 5 I'm comparing. Is 2 less than 5? Definitely 2 is less than 5. I should not change it. 2 itself is the minimum. I should not change it now. Flag is set already. I should not change this. This minimum will retain as 3 only and will be 1 only. And I cannot continue further because 5 is not less than 5, does not satisfy the condition, comes out of the loop. When it comes out of the loop, what you have to do? Check for the flag status. Is flag 1? Definitely flag is 1. You swap it. One element is already sorted. I want the second element to be sorted. Second element to be sorted, that means the index is 1. You change it. That means what? L of 1 should be swapped with what? L of min, that is L of 1 has to be swapped with L of 2. This it retains as it is L of 2. Sorry, L of 3. L of 1 is this. Second element should be sorted. Then minimum is going to be the 2 only out of this. Then I have to swap it. 1, 2, 3, 4, 5. I have swapped it. Is the point clear? Understood? Now, it's very simple. What do we do? It's already sorted. You can just see here. Will it going to end? Definitely not. It is going to continue with the further iterations also. Then it is going to check. See, in this, 2 elements are already sorted. In the next iteration, what it is going to take? It is going to take min as going to be the third element, then it's going to compare, then retains as it is, no changes. Flag will not be set to 1. Flag will not be set to 1 because it is 0 only. Change agadele, this is not going to change. And then again, this will be the minimum 4, 5. Again, it is not going to change. It is placed as it is. So this is what a selection sort. See here in that iteration, so many iterations it took. Okay. So you can just see here, in case of bubble sort, so many iterations it had taken. In case of selection sort, it has just taken only the iteration 1 and iteration 2 of the ith iterations. In terms of I loop, it has taken just two loops, two iterations by loop. So that's how it keeps changing. Okay, the algorithm, no, it keeps changing. The complexity of the algorithm, that is what we'll be discussing after this, the insertion sort. So the complexity keeps changing. The complexity of an algorithm keeps changing with respect to the elements and the order of the elements also. Okay, so we'll discuss that also. So next we'll go for the insertion sort. So what is insertion sort is also very beautiful. So what is this insertion sort? So let's consider that there is a teacher and they have just, they've just taken a register number, a person with a register number 5. She has got the answer sheet, and one more person, a register number. So she is having the answer sheet 5. Okay, one more person, the register number 3, he will give the answer sheet. So now, as soon as she gets the answer sheet, she start placing that answer sheet according to the register number, one at a time. So 3 she has got, she's going to place it here. And let's consider 2 she has got it, so she'll compare with 2 with 5. She's not going to place it. And again 2 and 3 is there, she's not going to place it. So she understands that 2 should be placed here. Again she'll get 4 now. Where she will place it? She's going to place it here. Is the point here? Insert the right element at the right position, taking one element at a time, and then we're going to do the backward comparison here. Backward comparison is done here. That you have to keep it in mind. Insertion sort means taking one element at a time and then keep inserting the element at the right position. Right position. One element, you place it at the right position. Here also, insertion sort also, we are going to divide this sort in terms of in terms of sorted list and unsorted list. We will have it. So we'll just go through now. Okay, so we'll just erase it now. Then okay, and then I'm going to do it. Okay, so we'll go for the insertion sort. So what is this insertion sort, we will try to understand. So here what we have, I'm going to take the same elements 5, 4, 3, 2, 1. So what I'm going to consider here is, I'm going to consider the first element. In this case, I is equals to 0 to n, definitely it is going to be the same only, and I should be less than 5, and in this case, I'm going to make it j should be equal to 0, sorry, j should be equal to greater than equal to 0, and I'm going to compare temp. I'm going to make temp should be less than L of j, okay, L of j. So here they've taken num list and all, it is going to be the same only. So just remember that j should be greater than equal to 0 and temp is less than L of j. The logic part, of course, I'm going to tell you now. Okay, because with respect to each iteration, you should be able to understand in a better way, that's what. Okay, so here what is that I'm going to consider? So let's consider the value of j is equal to what? J value is equals to I minus 1. It is I minus 1 backward comparison. Every time the j value was getting incremented in the previous two sorting techniques, here the j value gets decremented till it reaches 0. Minus 1 means we have to stop, keep that in the mind. So I'm going to compare, this is going to be each element, I'm going to compare, t is for temporary variable, each element, t is going to be the temporary variable, each element I'm going to take it at a time. So 5 is going to be an element right now. So this 5 has to be compared with now, okay, j is equals to I minus 1, I is equals to 0, what is the value of j initially? So 0 minus 1, it will become minus 1, that means, see here, we have a unsorted and then we have a unsorted and a sorted list. First element is there, what else I have to compare? First, the person has come, the person with the 5 register number, he has come here, register number 5 has come, but I don't have any elements for me to place it where exactly, I'm just taking it as it is. Okay, I'm just going to keep it as it is. So I'm not going to give any kind of comparison, it does not satisfy the condition because they say that j should be always greater than equal to 0. It does not satisfy the condition because that itself is the first element, I cannot compare. Now what I am going to do it, I am going to consider 5, 4, 3, 2, 1 and I am going to consider this as my second, one more person, 4, register number 4, he will give the paper. Now what I do, that 4 I will compare with 5 now, 5 was not there for me to compare because that itself is my first paper, that itself is my first paper, I cannot compare, I have placed as it is, okay, I have placed as it is. Okay, I have placed as it is now. It is sorted and the hilly, I have just placed as it is. 4 I have got it, I can compare with 5 now. Because 5 was already having, I am already having now. For first paper, I didn't had any comparison. That's why it is not done. 4 and 5 and 4 you compare is, okay, now what is the value of j? J is equals to, in this case, what is the value of I? I is equals to 1 now. J should be definitely 0. So 0 you compare with the, so let's consider this is going to be the 0 and this is going to be temporary variable. Is it less? Is temp less? Temp is less and j is also satisfying the condition. What you have to do? You have to shift it. Shifting is done here. L of j, you put it in L of j plus 1. Shift the element. From here, whatever the element is there, no? Whatever the element is there right now, 5 and 4 is there. 5 and 4 I am comparing it. Thus, that elements 5 is no more sorted. Now it has to be sorted. I have to shift the element now. No, that is not your position. It is telling you come this side, it is shifting. Okay, then I am going to shift the elements. I am going to put 5 here. I will shift it. This is L of j. L of j is L of 0 only, no? J is 0, right? This I am shifting it to L plus j of plus 1. Shift it here. When I shift it, it will be still 5 only. Keep that in the mind. So 3, 2, 1. J equal to minus 1 does not satisfy the condition, come out of the loop. Once we are done with it, once we come out of the loop, remember that you have to put back the element. I've comes out of the element. Now I know within 4 I know where I should place. I have two elements 5 and 4. I know how to place it now. I've shifted also. 4 will come now. Now after this shifting will take place. Shifting what? T you put it in. T you put it in where? What is the T also? We'll write it every time. T is 5 was here, and what is the value of T here? It was 4, it was 4, and now this T 4 value you should put it in L of minus 1 is there, no, J plus 1, minus 1 plus 1 is what? 0, minus 1 plus 1, you put it in J plus 1, minus 1 plus 1 is what? 0, so I have to put it here. Okay, I have to put it here. So I'll put that 4 in L of 0. That means I'll put it like this. 2, 1. Is the point clear? Next, what will I do? I'm going to consider this is going to be my temp. And in this case, what is the value of I? I value is equals to 2 now. It is definitely less than 5. And I have to consider J is equals to what? It is definitely less than this. It should be 1. Okay, it should be 1. It should be 1. Okay, then backward comparison. 4 is sorted. 4 is sorted. Now what will I do? I am going to compare 3 with 5. Compare 3 with 5. Is it less? Yes, it is less. Shift it. It is less. You shift it. So 5, 5, 2, 1. What is temp? Temp is equals to 3. Then I am going to place it here. Next, what will I do? I will take J is equals to 0. You compare this. See, this has to be compared with this. 0 is this only. This I am going to compare. 3 less than 4. Yes, it is less. Again, you shift it. This should be shifted here. L of J to L of J plus 1 means 4 only. 4, 4, 5, 2, 1. And J is equals to what? Minus 1 does not satisfy the condition because it has to be greater than equal to 0. It does not satisfy the condition. Now what I have to put? This 3 you put it in what? L of J plus minus 1. Minus 1 plus 1 is what? I have to put it in 0. I have to put it again in 0. It's already shifted, so there is a place. It is not misplaced. So it is 3, 4, 5, 2, 1. I've shifted. What is the value of I? I is equals to 3 now. And what is the value of T? T is equals to 2. And what is the value of J? J is equals to what? It is going to be 2. This is my T. See, what is T? T is equals to 2 now. This is 2. Start the backward comparison. 3, 4 is already sorted. See, 3, 4, 5 is already sorted. I have to compare with, I have to place it to where exactly I have to place it. So that means you compare 2 and 5. Okay, it is less only. Temporary variable is going to be less only. See, temporary is less only. If it is less, I have to shift it. So 5, 5, 4, 3, 1 shifted. Then J equal to 1. That means this. Compare the temporary. This I have to compare with temporary. 2, 4, 2. Less only. 2 is less. So again you shifted. 3, 4, 4, 5, 1. Again J equal to 0. 3 and 4 is compared. Now 3, 2 compared less only. 3, 3, 4, 5, 1. Again what I have to do it? J equal to minus 1 does not satisfy the condition, comes out of the loop. And put this temp 2, you put it in L of 0 because again it is going to be minus 1 plus 1, 0 only. Put that 2 here. So it is what? 2, 3, 4, 5, 1. Is the point clear? Similarly, how it happens? This will be temp now. It is again compared with this. It is compared with this. It is compared with this. It is compared with that. And this time also you should remember that how it goes. It will be 2, 2, 2, 2, 2, 3, 4, 5 it will be. Because first time 5 will be shifted, 2 will be shifted, 4 will be shifted, 3 will be shifted, 2 will be shifted, again 2 will be repeated. I haven't space for the 2 because I've already shifted. Then I can store my 1 value here for J equal to what? J equal to, for this case what? I equal to 4 and J equal to 3, 2, 1, 0 and place that one value in 0. This is basically an insertion sort. Remember, insertion sort means you can just remember that teacher is having a paper. As soon as one person gives the paper, she start arranging it one by one by shifting the papers. Oh, you come this side, this paper should come this side, this paper should. Keep shifting the elements and put that proper element in its respective position. Insert the element at the right position. That is what you mean by insertion sort. Clear? Okay, we'll go for the next slide. Okay, we'll go for the next slide. Okay, so here I have to tell you about the time complexity. What is time complexity? So in order to find, to check whether given number is prime or not, I can check the prime or not. It's having two factors, from 0 to n, from 0 to n by 2, or from the square root of n also I can take it. We have studied in the first PUC class. Similarly, the time complexity, different algorithm, we can write it for the same problem. So time complexity basically gives you the amount of time that is required to solve a given problem. Okay, and what is the space complexity? What is the amount of space that is required to solve a given problem? Okay, that is what you mean by times complexity and the space complexity. And especially important when you have a larger data set. Okay, and similarly here we have some key tips for estimating the time complexity. If you have, okay, so if you have no loop in the algorithm, there is no loop only in the algorithm, what is this? How do you estimate? How do you identify the time complexity for certain algorithm? That is what they have given here, estimating time complexity for a certain algorithm. If there is no loop only in the algorithm, that means to say that it is the time complexity is going to be 1. That means no loop means the number of instructions that will be executed will be fixed regardless of the input size. It is fixed always. That means the time complexity is 1. Okay, if it is having a single loop running from 1 to n means the time complexity is going to be n. Okay, so it executes n time depending on the input size, and we call such algorithm as, if it is having if it is having a single loop from 1 to n, we call such it's having a linear time complexity of n, and we call such algorithm as linear time complexity algorithm. And if you are having contains a loop within a loop, nested loop, as we have seen in all these algorithms, a loop within a loop will definitely be considered as the time complexity is n square, nothing but quadratic time complexity. And for such algorithm, we call it as a quadratic time complexity algorithm. Okay, the number of execution grows rapidly as the input size increases. If you keep increasing the size of the elements, definitely it grows, executions also grows rapidly. Okay, similarly we have mixed loops. Mixed loops means what? If both single and nested loop, there is a nested loop and there is a single loop also, then always the nested loop dominates the time complexity. That means always if I have a the single loop is there, then you have a nested loop. The time complexity of nested loop only will be considered n square. N and n square is there means it will be considered in the time complexity as n square only. So the final complexity is determined by the loop with the highest growth rate. N and n square means n square only. Okay, so we'll just go for okay, we'll go for the time complexity. That is what they have given for the bubble sort, selection sort, and the insertion sort. All these algorithms, whether it is in bubble sort or the selection sort, or whether it is going to be the insertion sort, the time complexity is going to be a nested loop. A loop within a loop, that means it's going to be n square. That means you got quadratic time complexity. So such algorithm definitely and quadratic time complexity algorithm we will consider. That means the number of comparison grows quadratically as input size increases. Is the point clear? So we have done with this chapter called sorting. Clear? So we'll wind up now. We'll continue in the next class. Hi students, how are you all? So we'll just continue with the next 3 chapters, that is searching and understanding of data and
one more chapter, that's the last chapter for the midterm examination, that is database concepts. Why is this high again? Yes, how is your energy level now? Of course, you're continuously watching all these chapters, but of course, I have just increased my energy level, so I'm just shooting this the next day. So how is your energy level now? So let's boost up your energy. Will increase your confidence level to face the exam gracefully, without fear, without tension, without anxiety. So let's start with the next chapter, that is searching. Okay, so what is searching? Searching is basically finding the position of an element in a list is called as searching. What is searching? Searching is finding the position of an element in the list, okay, in the tuple, in the dictionary, or whatever it is. We call it as a search. And there are three types of search. One is called the linear search, binary search, and one more is going to be the search by hashing technique. Okay, so we'll just continue with the next slide. So that's going to be a linear search. And of course, this chapter is all about the search only and how exactly it works. So we'll just take up one at a time. Okay, one at a time. So we'll just understand what is a linear search. So linear search is basically the simplest search. Let's take an example. So I'm going to take a number 5, 7, 8, 2, 4, some random numbers I'm taking, and I'll ask you to find out whether an element 8 is present or not. Okay, you're supposed to find out 8 is present or not in this given list. So what do? Very simple. You just look at the number one at a time. Okay, so 4, 5, 7, and then 8. You just seen 8. It is there. That's what you did, no? So whatever the way we are finding out the element, it's going to be the simplest way of searching, right? That itself is the linear search. What is linear search? A linear search is the simplest searching technique of all the searching among all the searching techniques. Here, we're going to traverse each and every element one after the other. I'm going to traverse each and every element one after the other and keep comparing the elements. How did we do? Is 4 equal to 8? Is 5 equal to 8? Is 7 equal to 8? 8 is equal to 8. Yes, the element is found. That's what you did. So that is what a linear search is all about. And linear search is also called what? Is also called sequential search. Sequential means what? One after the other only, right? It is also called as serial search. Is the point clear? And here, it is especially useful if we have small data set, or we can say that if it's unordered collection. Elements are not ordered. If it's ordered, unordered, whatever the case, definitely linear search is going to be the best case and the simplest searching technique. So we'll just learn the algorithm also based on this searching technique. So we have a binary search. So first we'll understand what is linear search, the algorithm, how it works, and then we'll go for the binary search. Okay, so what do we have here? So linear search, I've taken some numbers also, some 3 different lists we have. So we'll just take the first list here. So what is that list? 8 minus 4. I think you're able to see this entire number set. So we have 8 minus 4, 7, 17, 0, 2, and 19 we have. Okay, and you're supposed to search 17. So what is that? The key element is going to be the 17. Search element, specific element, key element is the element to be searched. Very simple. I'm supposed to search 17. So how do you do it? Very simple. Linear search is what you have to traverse from the beginning till the end. From the beginning means what? You know that list always starts from the index 0. So whatever the number I'm writing now is going to be the index 0, 1 and 2. So this is going to be 3 and this is 4 and this is 5 and this is going to be the 6. Okay, totally 7 elements and index starting from 0 to n minus 1, 0 to 7 minus 1, that is 6. So I'm supposed to compare whatever I did, no? So now I need to write an algorithm for that. So we have to start from I, index I equal to 0. So let me take I. And then I have to compare till where? From here till here I have to compare. No, here means what? Till the end of the element. End of the element means what? It is given as index n. That means I should be less than or equal to n. So what I have to do in each case? In each case, I have to compare. Is it equal? Is it equal? Is it equal? So I have to compare. So comparison is done here. That means instead of num list, you can just observe from the beginning of my lecture, wherever the list name is taken as num list, I'm just taking it, keeping it very simple as L for list. Okay, I'm just keeping it very simple, L. Okay, L of I is the index here, equal to K. Hope you know the difference between equal to and equal to. In algorithm, that's fine if I write equal to also. But in the code, it should be equal to. Since you should not have any confusion, I'm just writing as equal to. Okay, and after that, what we have to do? So after that, I just have to increment my I is equals to I plus 1. Okay, let me just check out now. So what is it? It's going to be 0 now. 0 is less than or equal to 7. Definitely, yes, it satisfies the condition. What is L of 0? L of 0 is nothing but 8. Okay, 8 equal to 17. Definitely not. So increment the value of I. So element, if it is say, I'll say it is not equal, or else I'll continue, else increment the value of I. I is nothing but the index. Increment the value of I. I've just incremented. So go for the next. 1 less than or equal to 7. Yes, it satisfies the condition. What is L of 1? L of 1 is nothing but equal to what? Minus 4. Minus 4 equal to 17. Definitely not. Increment the value. So here I'm incremented by 1 and this is incremented by 2. That means incremented not by 2. That means 1 plus 1 is equals to 2. That's. Okay, so let's just go for the next. 2. 2 is less than or equal to 7. Yes, it satisfies the condition. What is L of 2? L of 2 is 7. 7 equal to 17. No, it does not satisfy the condition. It does not satisfy the condition. Go for the else part, increment the value of index. That is 3. Is 3 less than or equal to 17? Yes, it satisfies the condition. L of 3 is what? 17 equal to 17. Yes. That's what we want. Element is 17. Yes, we found. Yes, we found. Element found at position what? It is found at position 3. Will we say as 3? In normal users, what will they say? They say that element 17 is present in 1, 2, 3, 4th position. So we'll just increment the value of index. Index plus 1. Here in this case, I plus 1. We'll just come out of it. We'll just break. How do you come out of this? In case of code, we'll write break. Come out of this loop and this just come out of the loop. Automatically, it just comes out. Okay, if it does not satisfy this condition, we'll go for unsuccessful search. Okay, we just have to come out of the whole loop only. And we just have to say that element found at position and come out of the program itself. That is very, very important. Anyway, it is going to be an algorithm. You need not have to worry. Just write stop here and come out. Yeah? So that's about linear search. So let us take another example also here. So we have another example here, 8 minus 4, 7, 0, 2 and 19, 17. So I need to find out 17. So in this case, what are the number of, okay, in this case, how many iterations we required? In this case, we need totally 4 iterations. Ma'am, how 4? 3 only. We started from 0, no? So 4 iterations. Iteration 1, 2, 3, 4, 4 iterations. In this case, if I want to search 17, how many iterations I needed? I need 1, 2, 3, 4, 5, 6, 7. 7 iterations means n iterations I needed. 17 is at the end, no, so n iterations I needed. So what about in this case? In this case, I'm supposed to find out 17 now. The best case, it is present in the first element itself. In the first location itself, 17 is the best case. The best case, isn't it? So this is about the linear search. Okay, we'll go for the next searching technique that's called binary search, a beautiful searching technique. So what is this binary search? Binary search, before we understand binary search, we'll just take an example now. Okay, see now what is the problem with linear search? The problem with linear search is, for example, 17 was at the end. 17 was at the end. I'm supposed to find out, okay, till n comparisons, n iterations I have to find out. If it is not there also till n iterations I have to find out. In the other case, I want to reduce the number of iterations even though Even though 17 is here, even though 19 is here, any element is at the end, last position also, even though if it is at the last position also, I need to reduce the time. I need to reduce the time. How to reduce the time for processing? Need to reduce the number of iterations. How to reduce the number of iterations? Is there any method of searching technique wherein that can be reduced? Yes, we have different techniques. That is what we will be studying now. So why other searching? Because it is taking more time. Since the element is at the end, you are taking more time. I don't want that. Search it, taking less amount of time. Right? So we can't wait. Right? So we need to go for the next searching technique. Let's consider that I will give you a dictionary. I'll give you a dictionary and I will ask you to search a word called zeal. Okay? Do you have the zeal to work for computer science examination to get 100 out of 100? And what 100? We are not writing practical exam. Okay, 70 out of 70. Okay, so the best, whatever you've acquired the knowledge, whatever the wisdom you've acquired it, you want to give your best. Yes, definitely yes. Okay, so I'll ask you to find out the meaning of the word zeal we know it. That's fine, you listen to me. Okay, zeal you're supposed to find out in the dictionary. What will you do? Will you start from the beginning of the chapter till beginning of the dictionary till the end? What is my question? My question is, I'm asking you to find out the meaning of the word zeal in the dictionary. Will you start searching the meaning of the dictionary from the beginning of the page, from the first page? No. You will directly go to, for example, if the dictionary is of let's consider it's going to be of 500 pages. You will directly go for 490 page or 498 page or 495. You will try to find out, no? Similarly, I'll ask you to find out the meaning of the word called anxiety. Do we need to have anxiety? Everyone is having anxiety while writing the exam. Everyone. No, ma'am, I don't have. Okay, but we'll have some tension, some stress and all, no? We should not have. So we should not have anxiety. Why does anxiety will come? For that reason, we will know the meaning of this anxiety in the dictionary. Will you start searching the meaning of this anxiety from the end? And A is in the beginning only. Why will I go there? Definitely no. You will start from A only. Z means you will directly jump to 419 and 495 page. You will jump. A means in the beginning only. I did not have to go to the end. It is in the beginning only. For example, I need to find out the meaning of the word called meditation. Everyone is telling do meditation, your stress will be released. Meditation, what is exactly meditation? Is it like just keeping your eyes closed and then, just listening to that music? Okay, not deviation. So we'll just go for meditation word. Meditation is in the middle. That's what I meant, right? So it's very clear that we know where to find. Since it's alphabetically arranged, since it is ordered, we will be able to find out the meaning of the words quickly when compared to find the meaning of the word if it is just randomly placed. If the meaning of the word is randomly placed, how do you search? It's very difficult, right? So here also, this binary search basically works for the sorted elements. It basically works only for the sorted elements. It applies even for the strings also, even for numbers also. It applies only for the sorted elements either in ascending order or descending order. But we have taken the algorithm only for the ascending order. So let's understand how exactly the binary search works. So I've just taken some example here, 2, 3, 5, 7, some numbers is there, some 15 numbers. It is there in the textbook also. I think it is very helpful if I take this example. That's why I'm taking this huge numbers here. So what exactly? So whatever the example I gave, it is the same thing. That means you're supposed to find out the meaning of the word zeal, just go to the end. Meaning of the word anxiety, come in the beginning only. A only it is, N it is in the middle. So similarly here, binary search works based on the boundary method. Boundary, you're fixing a boundary and searching. You're fixing a boundary and you're searching. Let's consider a very simple example. I'm going to take it. I'm going to take it a number like 10, 20, 30 and 40. Okay, I'm just taking some simple numbers. So I'll just ask you to find out, okay, I'll just ask you to find out whether number 30 is present or not. 30 is present means linear search one after the other. I don't want that method. 50 means it will take 5 iterations. I don't want. Now, I'm supposed to search binaries and search the 30 element in using binary search. Means just find out the middle element. Okay, then it is there only. So, for example, this is index 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So, what is the middle element? 0 plus 4 by 2. It's 2. Element is found. I want to find out 10. Will you have to search in this part of the list? Here, this side, left side. Yes, 30 we searched, it is not. Now, search element is 10, let's consider. If you have to search 10 means 30 it is more only. Search element is less. I have to search in this part. Boundary is fixed from here to here. Initially, the boundary was from here to here, the entire. Then later, I just made it, I divided it from here to here only. 10 is from the left side. After search 50 or 60, then I have to go in this part. We fix a boundary and then work. Is the point here very simple? That's what they have given here. So here you have to fix the boundary means you need to have the first value, or else I can call it as an index as beginning, end, and then mid. Here they've taken as first, last, and then the mid. This is the first index, it is 0. It is going to be the last index. Last index is equals to n minus 1. That is going to be 4. And always your element should be first less than equal to last. It should always be within this boundary. No, it cannot be present in somewhere there. It should be in this boundary only. First, it should be less than equal to last. That is the case. Clear? Now, every time what you have to do, keep finding the mid element. How will you find out the mid element? Mid element is find out by using a step called what? I'm going to find out the 1 minute. So I'm just going to find out the mid element by using this formula, first plus last by 2, beginning plus n by 2. That's going to be this. That's what I did. 0 plus 4 by 2 index. After that, you check it. You compare it. Is my L of mid equal to key? Is it 30 equal to key? Yes, it is true. Then what we will do? So we'll just say that element is found at position mid only. We will say 2. But normal users understand third position. That's why it is mid plus 1. What if it is not true? Either it should be less than, 10 is less than the mid value, or it can be greater than the mid value. What if it is less than L of mid? That means I have to change this part. This is fixed. Means what? First is fixed. The beginning is fixed. End I have to change. What I have to change? End at the last I have to change. It is changed from here to here. What is this? This is nothing but mid minus 1. What is this? If the element is going to be search element is less, you make the last as mid minus 1. From here to here, change the last as mid minus 1. What if the element is greater? 50 you have to search. Then you change this because this is fixed. Change this. I have to search from here to here. 30 I have found out 30 is not equal. Now I have to go for 50. 30 I found out the mid value. It is not equal to 50. I then have to search from this part of the array, this part of the list. This is fixed. This I have to change. Change what? Change the first to what? Mid plus 1. Change it to mid plus 1. That is important. That's all the algorithm is all about. And why is it called as a binary search? We'll understand that. So we'll just take up 1 minute. Just give me some time. Okay, so I'm just taking it here. Okay, these elements only. I'm going to write the index also because that is very important. Okay, so we will write what is first. I'm just writing first and LA as last. Okay, let me write LAST only because L is there as the list. Okay, then F is less than or equal to last. And then we have mid here. I have mid. And then what is L of mid equal to key? And what if key is less than L of mid? Okay, similarly the other case, key will be greater than L of mid. These are the different cases we may come across. Okay, right now what is the search element? I just have to search the element 2. See, let's consider that I want to search 7. Okay, let me take the search element as 17 I want to search. So how do we proceed? The first iteration, in this case the first iteration is what? Iteration 1. This is iteration 1. First is going to be 0. This is 0. This is first and this is going to be the last. What is last? It is 14. 0 is less than or equal to 14. Satisfy the condition. What is mid? Mid is equals to 0 plus 14 by 2. 0 plus 14 by 2. 7. L of 7 equal to 17. Yes, L of 7 equal to 17. If the search element is 17, definitely find out. You just say that it is found out. I'm going to stop it. Yes, I found out. Stop it. You come out and say that element is found at 7 plus 1, that is 8th element it is found. 8th location it is found. Okay, we'll take the other case now. What is the other case? Please understand. Next, what I'm trying to tell you is why it is considered as binary search. To teach you that, I have to tell you along with the explanation. We'll just take the search element now as 2. This is the search element. Okay, key element. Okay, I'm just taking the key element as 2 now. I've changed this to 2. Is 17 equal to 2? Definitely it does not satisfy the condition. I'll just shift it now. Is my key element less? Yes, key element is this side. It is this side. What I have to change now? Then I have to search from here to here only. I have to search only from here to here. Only from here to here. This is the boundary. This is the first, this is the last. Change the last to what? Mid minus 1. What is last? Last is equal to mid minus 1. Mid is what? Mid is going to be 7 minus 1. That is last is equals to 6. Clear? Now we'll come back. Second iteration. What is first? First is equals to retain as it is because I'm just searching this only. 6. So 0 is less than or equal to 6. Satisfy the condition. 0 plus 6 by 2. 3 by 2 it is 3. L of 3. What is L of 3? L of 3 is 7. 7 equal to 2. It is not satisfying the condition. So L of 3 is 7. 7 equal to 2. It does not satisfy the condition. What we will do? I'm just going to write it as what? Check the condition. Is 2 less than 7? Yes, it is less than 7. Right? I'm just checking is key element is 2. Key less than L of mid. Then L of mid is 7 only. No, 2 is less than 7. Yes, what I have to change? I have to change the last. Last will be equal to what? Last is equal to mid minus 1. 3 minus 1. What is 3 minus 1? L is equals to 2 now. Then I have to search I searched from here. I was searching from here to here. Then I shifted to this. Then I shifted to this. Okay. Then I need to search. I searched this. Okay. 0 to, okay. This is my mid. Okay. So, sorry, this is mid now. Mid is equals to what? Okay, I think I made a mistake. 1 minute. Last will be equal to what? Last will be equal to, I have to change. Okay, I have to restrict my change. Okay, 3 does not satisfy the condition. Definitely key is less. When the key is less, definitely last is equal to mid minus 1. What is last? Last is equals to, let me write again. See here, mid is what? 3 minus 1. I have written correctly only. Last is equals to 2. Okay, 2. Last is equals to 2. That means to say, I have to search from here to here because 7 was not at all equal. It is less. I have to search from here to here only now. Again, you calculate the value of mid now. Third iteration, 0. Last is 2 now. Okay, 0 is less than or equal to 2. It satisfies the condition 0 plus 2 by 2. 2 by 2 is what? 1 only. What is L of 1? L of 1 is equal to 2. L of 1 is equals to what? 3. Is it 3 equal to 2? It does not satisfy the condition. 2 is still less than 3. 2 is less than 3. Then I have to restrict my search from here to here. We'll see the last. Last is equals to what? This mid minus 1. What is mid now? I've just found out what? 1 minus 1, that is equals to last equals to 0. They come here. 4th iteration 0. Last is 1, 0 only. 0 is less than or equal to 0. It satisfies the condition. So now 0 plus 0 by 2. What is 0 plus 0 by 2? 0 only. I've got the mid as 0. L of 0 equal to 2. L of 0 equal to 2. Yes, L of 0 equal to 2. 2 equal to 2 satisfies the condition. We have got it. Just say that element is found at 0th position, or we may say that 0 plus 1 is found in the first position. Is the point here? See here, every comparison is telling you, I'll just show you this part. See 7, 3, 1, 0. Just see this, 7, 3, 1, 0. Every comparison gives you information about the part of the list where the key element can be found in the search area. What I'm trying to tell you? I'm trying to tell you that every comparison, whatever I'm comparing, every comparison gives you information about the part of the list where key element can be found in the search area. It's given to give you information. That means, is it in this part? Is it in this part? So initially it was this, I have to search from 0 to 15, 0 to 14, sorry. Then it reduces to 0 to 7. Okay, from 0 to 14 to 0 to 7, from 0 to 7 to 0 to 3, 0 to 3 to 0 to 1, then it is 0. That means every unsuccessful comparison reduces the number of elements to be compared by half. 14, 7, 3, 1. Reduce only, no? Every unsuccessful comparison reduces the number of elements to be compared by half. That's why it is considered as binary search. Binary means 2 only, no? 2. Reduces the number of elements to be compared by half after every unsuccessful comparison. That's why it is called as binary search. Clear? So we'll just go for the next.
Yep.
So what are the different applications we have? We have searching in dictionary, telephone directory, indexing in database, implementing routing tables, and data compression code, etc. Okay, so next what we have is searching by hashing. Searching by hashing. So I don't want the number of elements to be compared. For example, I want to search 2 in the previous case. Of course, I took 4 comparisons. See, in linear search, it was just 1 comparison. If you consider the same thing, linear search, if you want to find out the value of 2 means, it will just give 1 comparison. 1 iteration only. If I have to do here, then it will take 15 iterations in case of linear search. In case of binary search, definitely it reduces. Definitely it reduces. I think definitely it is going to be 4 comparisons only. 4 iterations only I need it. Similarly, I don't want so many comparisons also. I wanted the element to be searched in one simple technique, one comparison only I want. I don't want to keep on comparing. I want in one step. That is what hashing technique. So what is hashing technique? Checking the presence of an element with just one comparison by storing the element in the predefined index. You store the element in such a way that you know the index already where you're storing. Find out, calculate that index first. In one statement, you can calculate the index and then start comparing. With one comparison, you will be able to find out. Is the point clear? That is what you mean by hashing technique. Checking the presence of a key in a list using just one comparison by storing element at a specific index position, calculated using an hashing function. There will be a certain hashing function. Using that hashing function itself, you will be able to calculate the value of the index where the element has to be stored. Is the point clear? So, we'll just see here, we have certain elements, find out the, okay, we'll just see this and then come back to that. And how do you find out the hash? How do you find out what I can tell you? Calculate the index position using hash function. There should be some function which will calculate the index value. Right? So how will it find out? Then what exactly does hash function? How will it calculate? There are different methods. One simple method is using a reminder method. How is it done? Element modulus size of hash table. Element modulus. Modulus gives you the reminder. For example, I have an element here. I have an element as 34. 34 modulus hash table. Let's consider I have a table where I have to store all these elements in one table so that in one comparison I'll be able to find out. I'm going to find out using a hash table with what do you want to find out? Hash table size is what? 10, 20, 30, 40, 50. Whatever you want, you can take the hash table. The way you want, you can take it according to your requirement, you can take it. Okay, I want to take 10, 10, 20, 20, 30, 30, whatever you want, you can take it. Okay, I've just taken 10 for the simplicity's sake. 34 modulus 10. Okay, so 34 modulus 10 gives you what? 4. This 34 will be stored in the 4 index. And 16 will be stored in the index. 16 modulus 10 is what? 6. This 16 will be stored in 6. This will be stored in 2, 3, 0, 7, 1. Like this, the respective list elements will be stored in the index found out by the hash function. Is the point clear? So that means we have a separate hash table here. So in this hash table, I have an index like 0, 1, 2, 3, 4, 5, 6. Okay, and then 7 will consider. So 0, nothing, 0, 80 I will store. 1, where is the index? 151 I'm going to store. 2, I have 2 only. 3, what is it? 93 I have to store. 4, 34 I have to store. 5, nothing is there. And 6, something is there. 6, we have 16. And I have 77. This table is called hash table. When is it only this much? I will have till 10, 8, 9, 10 because I've taken the hash table as 10. It can be more than this list table also. It can be anything also. That's what I told you. Is the point clear? Then how will you? This is called the hash table. This hash table will help you in finding it out. First, calculate the index of that. Calculate the index of that particular element. As soon as you get the element, calculate the index. So what is the index of this 80? What is the index? Index is going to be 0. Then if it is, it just got 0. Then you say it is going to be in its point. Find out if the position is going to be 0. We have 34. Then the index is going to be 4. 34, the index is 4. 93, then it is the index is 3. Because the reminder, and everything is fine. What if I have a number like, what if I have a number? So what is this number? Right now my number is going to be 34. I have similar number like 14. 14 and 34, the reminder will give 4 only. No, ma'am, what is this case called? It leads to collision. It just leads to collision. It leads to collision. So if you have an element producing the same index, that leads to collision. Okay, that leads to collision. Then when you have a collision, find out a solution for that. How do we handle that? A mechanism to overcome this collision is known as collision resolution. Is known as collision resolution. Very simple. Mechanism to overcome this collision is called as collision resolution. Okay, these terms you have to remember. And similarly, we have perfect hash function. Each and every element in the list, if it is having a unique index value, each and every element in the list is having a unique index value, that function is known as perfect hash function. That function is known as perfect hash function in this case. So everything is unique only, it becomes a perfect hash function. It may vary. For example, if I add for this list, if I had 14, then it is not a perfect hash function. It is not a perfect hash function. Is the point clear? Understood? Very simple. Very simple. Just with one comparison, I'll be able to find out whether the element is there or not. As such a simple technique as well. Clear? So that's what I told you, collision resolution and perfect hash function. And hash table is what? It's basically a list only wherein you're going to store the elements, list elements at the corresponding index value produced by the hash function. Okay, so we'll just continue with the next chapter. That's going to be chapter 7, understanding of data. We'll understand what does data all about. Okay. So what is data? I think you've learned this. Data is basically raw facts, unprocessed items. That is what you've learned. That means it is not an assumption. It's not hypothetical. It's the real thing that has occurred. Okay, for example, Radha scored 70 marks in computer science. That means it has occurred. She has scored. Okay, there is a person, Krishna, has scored 70. There is another person called Raman. He has scored 25. It's a fact. It's a fact means we have to accept it, right? It is going to be a real thing that has occurred as a fact. Okay, it is basically known as data. Okay, real fact or the raw data or the unprocessed item, we call it as data here. So it can be in terms of characters, numbers, information, transactions. It can be images, it can be audio, video, it can be anything. So they've just classified the data as in terms of personal details, transactions, multimedia, images, audios, animations, documents, online posts, or it can be the web pages, messages. All these things is considered as a data itself. Is data important? Definitely data is important in each and every field, isn't it? For example, you have just posted something. Okay, let's consider that you're just commenting, ma'am, you're not at all teaching well, you can improve on this, this concept is not clear to me. Okay, on the other side, ma'am, your video is really good, I'm really liking it, thank you so much. So there is some kind of comments that you're putting. Okay, there is something, you're liking this video. What is it? Everything is related only. So all these things is very, very important from the channel perspective because it carries a high business value. Because your comments, your post, liking. For example, if you like something, then you're going to get related. For example, you watch some video related on, video about it, about Dhoni. Then you'll get tons such videos on Dhoni. Virat Kohli you watched, so you get some 10 videos on Virat Kohli. That means each and every data, you're commenting, you're liking, you're just watching, each and everything is recorded, it is being stored, it carries in high business value because they're making business out of it. They're making money out of it. It carries in high business value, right? So, and one more thing, let's consider another example, like, they say it's in month-end sales, year-end sales, the sales, that they do it. Okay, basically they want to improve their business. That's what they have recorded. Okay, this is what the business. I didn't get it. We will give you a discount. That means they have made some kind of analysis, right? So monitoring and analysis of the market behavior. Okay, for example, each and every advertisement that you see, that you click will be recorded. Amazon is going to record each and every click that you do it. Because, like each and everything is important for it. So many users are using it. Okay, and these, cab booking apps, they're creating this dynamic pricing. For example, there is some college fest in the call. Okay, there is some college fest and the people will be booking so many, so many bookings will be there on that particular day. So they'll suddenly increase the price for that particular place. Dynamic pricing during festival season. Okay, and similarly, we have the other private buses, transportation, they'll increase their price based on certain analysis of data only. And hotels, they'll give you some kind of unhappy hours because they are getting customers on the weekends. They want to improve on their business. They'll give you a kind of discount, say that happy hours on the weekdays to attract the customers. Are they wrong? Definitely wrong. They have to make money. They have to improve on their business, and that's how. They can improve on that only if they work on that. And that data is important, isn't it? So each and every data, whatever we are commenting, posting, okay, whichever field you take it, everything is important. It has to be recorded. It has to be processed to make important decisions. Clear? So we'll go for the next topic. That's going to be different types of data, structured data and unstructured data. In this chapter, they've just classified it as only two types, semi-structured. They have put under unstructured only. Don't get confused. Okay, majorly it is only two type. Under that, they have just included that both structured and unstructured, and they made it as a separate category in the first year. But here they've put under unstructured only. Structured is what? That means they have a predefined structure. It's already organized, well-defined format. Schema is already known. Okay, that means it is organized. Okay, it is in the form of tables, rows, and rows and columns. So everything is easy to store, easy to retrieve, easy to update, easy to modify. A database is going to be a very good example for the structured data, and you know that 20% of the data is a structured data, and 80% of the data around the world is going to be an unstructured data. Here we don't have a predefined format. No predefined format, no schema. It can be an image, I can get an image, I can get a comment, I can get a like button, or someone can just like it. Social media post, newspaper. On first day, on this day, on today, I can just see the paper. I have only complete ad in the first page. In the second day, I can have some important images and only the text. And next day, only image. Okay, no text only. Okay, someone's birthday is there. Okay, so like this, there is no particular format. Okay, newspaper is a very good example. Website is a very good example for the unstructured data type. Is the point clear? So anything else you have to, yeah. So you can also see something called metadata. Data about data is called as metadata. Let's take an example for email. So email also they have put under unstructured only. Don't get confused. So it's in case of an email, we have details like subject to address, from address, main body. These are all the data about data. It's not a data. To, from, then subject, body. It is all about data, which is called metadata. Then another very good example is going to be the image. So what is the file name? What is the size? What is the type? Is it PNG? Is it JPG? Or what is the resolution of the image? These are all the information related to the, this is the information related to the image, not the image itself. Image itself is the actual data. Information related to the image will become a metadata. Data about data is called as a metadata. Clear? Those will come under database concepts as well. Okay, so we have some important definitions also. So the data, the steps involved in data processing activity. The important steps involved in data processing activity is called as data processing cycle. What are the steps that will come? You have to collect the data, data collection. Once you collect it, you store the data, data storage, and you have to process the data. Simply, if I have a huge amount of data, it is of no use. Okay, first you gather the data from various different resources. It can be in terms of handwritten records, or it can be in terms of CSV files, or it can be in terms of using a specialized software like DBMS. It can be any particular software where you can get the data, collect the data from various resources, and store the data so that it can be used in the future permanently. You store it in the secondary memory devices so that it can be retrieved, manipulated, updated for the future reference. That's why you have to store it, right? Okay, and similarly, we have a data processing. Simply, if I have a huge amount of data, it doesn't give you no value at all. You need to process it, you need to analyze it, gather some kind of information from that. You need to, if you draw some conclusion, only then you will be able to take some value-added decision in the company, for the company. Right? It carries a high business value when you are able to, only when the data is processed, only when the data gives you helps in taking the right decisions. Then only it's going to be profitable for the company, right? That happens. Decision making happens only when you process the data. So how can you process the data? Very simple. We can process the data by making use of some simple techniques called statistical techniques. Which are the statistical techniques? We have something called as a measure by central tendency, and measure by and measure by variability. So what is measure by central tendency? You have a huge data. Let's say that a huge data is there. What will I do with that huge data? I just want to know, I want to have some idea about that huge data. One idea about huge data. Huge collection of data, one idea about that huge data. Measure of central tendency gives you a single value. Okay, it's a single value from some idea about the entire data set. What is measure of central tendency? This gives you a single value that gives some idea on the entire data set. Okay, for example, I have a percentage of all the students in the class. I know the percentage of all the students in the class. I just want to know the class percentage. I want to know the class average. One value have to tell me how the class has performed. I don't want to see all the class students percentage. I don't want that. I just want one value that has to indicate the class average. Average only, right? The mean gives you the central tendency. Central tendency is basically a single value that gives an idea about the whole data set. Whole data set is all the students' percentage. One value, that's the mean. And mean is basically the average itself that you already know. It's highly influenced by the outliers. Outliers means what? It is the extreme large value and extreme low value is called the outliers. Okay, we'll just see the example here. And we'll go for the median. Median is basically the middle value, and you have a huge data set, and that data set has to be arranged in either in ascending order or in the descending order, and take out the middle value. That will become the median. And what if we have the odd number of values? Very simple, the middle value itself. So let's take 1, 2, 3, 4, 5. This is the odd number of elements data set I have it. I want to find the middle value. Middle value is going to be 3 only. 3 only, no doubt. What if we have even number of elements? Now, how do we take the median? Very simple. Average of middle two values give you the median. Average of middle values give you the median. 3 plus 4 by 2, 7 by 2. 7 by 2. 3.5 will be the median for that. That's the point here. So remember here, central tendency gives you a single value, but that gives you an idea about the whole data set. And let's find out. An usual measure of central tendency is the mean, median, and the mode. Mode is the most frequently occurring element in the data set. It can be most frequently occurring element in the data set. I just like red, green. In the data set, I have some colors like red. Okay, let me say that what are the different colors of chudidars I have. Red, green. Red is the most frequently used color in this data set. So red becomes the most frequently used. That is the mode. Okay, let's consider I have dresses like red, green, blue, yellow. What is the mode? No mode only. There can be no mode in the data set. For example, red, green. We can have a multiple mode also is possible. Remember, mean, median is applied only for the numerical values, whereas mode can be applied for the numerical values, even for the strings, even for the characters also we can apply this. Clear? No mode also, we can have a data set with no mode. No mode means what? Nothing is repeated. Okay, so what if it is repeated like red, green? I can have two modes. I can have multiple modes. Okay, let us see example for all these central tendency, mean, median, and the mode. And going to be what is the mean? Mean is nothing but the average. So I have some values here, 3, 4, 7, 8, 2, 7, 5. So just find out 4, 5, 6, 7. So divide by 7. This gives you the average. Normal average only. So the same data set, I'm supposed to find out the middle, median. I have to find out, arrange these elements in the ascending order. 2, 3, 4, 5, 7, 7, 8. So how will you find out? This is going to be 3 and this is going to be 3. It's going to be the median is going to be 5. It's going to be 5. Clear? So next we have, it's going to be median 5. And the mode in this case, what is repeated? You can just see 7 is repeated. Nothing is repeated. So 7 is the mode in this case. Clear? Understood? So we'll just go for the next one. Measure of variability or dispersion. Measure of variability or measure of dispersion, we call it. So what is measure of variability? Measure of variability gives you an idea or it indicates how the value is spread across the mean or around the mean. What? I'm telling you, measure of variability means how the values are spread. How the values are spread around the mean. that gives you measure of variability. That means it gives you the degree of diversity in the data set. Our degree of diversity in the data set is what? The measure of variability. So measure of variability is basically done using two methods. One is the range, using the range, and using the standard deviation. Range is very simple, difference between the maximum value and the minimum value. Okay, difference between the maximum and the minimum value in the data set. And standard deviation is basically each value, how each value varies from the mean value. How each value differs from the mean value. That is what a standard deviation gives you about. I'm telling you, measure of variability gives you what? How the values are spread around the mean. How it is spread, that is what it gives. Okay, I'll give you an example. You'll be able to understand in a better way. Let's consider some element. The same thing I have taken here, 3, 4. See, I told you about the outliers here. So what is an outlier? Extreme high value and extreme low value. For this, if I take the extreme high value is going to be around, let's consider extreme high value is 100. Don't you think that my range is going to vary? 100 minus 2 is what? 100 minus 2, then it will be 98. The range is 98. Absolutely wrong. The range and even the mean and the average, it's be highly influenced by the outliers. That's what I meant. Mean and or the average and even the range is highly influenced by the outliers. If I have such outliers, extreme high value, extreme low value, then it's definitely affecting my value. That will be a wrong value. Okay. So we'll go for the standard deviation. So standard deviation, they've taken the height in terms of centimeters, and x bar is going to be the mean, the average only. X minus x bar whole square. So this is the formula they have given here. Okay, summation of, okay, it is basically I equals to 1 to n and x of I x bar whole square divided by n. This is going to be the standard deviation formula. Okay, I want to tell you why exactly the standard deviation is used. You'll be able to understand. Let's consider an example, I'm just taking an example. Let's consider Virat Kohli, okay? Virat Kohli, okay, how he's going to do his course. Okay, let's consider from 0, 10, 20, 30, 40, 50, 60, 70. Okay, and you should not take me wrong if I'm telling something, it is not exactly how he plays, just an example, please forgive me, okay? So I'm just let's consider batsman V. Okay, not Virat. So let's consider batsman V. And this person, he is always, let's consider the 10 test matches or 10 matches, his scores I'm going to consider. So his scores for the 10 matches is here only. 50, 51, 48, 49, 50, 51, like this only. It is tightly clustered. Standard deviation is less. Tightly clustered, tightly bounded, I can tell. The consistency is high. The average, if you consider also average, see, let's consider another person, let's consider batsman B, and he has scored 100 also. Let's consider 100 also he has scored 0 also, he has scored 50 also, he has scored 80 also. Average may be 50 for him, but there is a lot of variation. A lot of variation is there from each and every match what is playing, not consistent. 0 also, 5 also, 10 also, 100 also, then 120 also, like that. Variation is there. How each value varies in the data set around the mean is called as measure of variability, or measure of dispersion we call it. So that is, easily, you'll be able to find out using this standard deviation. Clear? So this is slightly clustered, it's widely spread. We call it as widely spread. Hig spread agide, consistency hegide. That's what we will be able to find out using the standard deviation. Even though in all these cases, mean, median, mode, everything may be same. But the standard deviation will give a clear picture how it is varies. How the variation is there. Variation. The name itself says. Okay, it's not understanding of data, it is database concepts. So what is chapter 8? Don't get confused with the heading. Of course, I'll be doing database concepts only. I think this slide has got interchanged here. So chapter 8 is what? Database concepts. How's the energy, students? Great? Low? It should be high only. Please increase your energy levels. Drink some water. Okay, please increase your energy. So we'll just do the last chapter. Please have the zeal, energy, and the motivation to complete, not the motivation. Please have that inspiration, okay, to finish off with this particular chapter, that is database concepts. Okay, well, just see, in the last chapter, you've already understood what is data and what is the importance of data. Each and everything what we will be doing in the company or anything, whether it is an educational institution, whether it is an airline company, whether it is any other business company, anything, importance of data is very, 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 plays a significant role. So, okay, data is important, that's fine, but how do we store it? See, you've seen the steps also, no? One is going to be the data collection, data storage, and then you do the processing. So, processing part, we have learned a little bit statistical techniques. So, we'll go for the processing part later. First, we will understand how do we store the data. How can you store the data? By using the secondary memory devices, right? So, now, is there any, it's not just about storing the secondary device, it's about how well organized, how, what are the different ways of storing the data in the secondary memory, so that very efficiently I'll be able to retrieve the data at any given time. At any given time, I should be able to retrieve the data very quickly, easily. I should be able to manipulate the data as well. That's what, right? So now we will talk about the database concepts. But before we understand the term database, we'll just understand what are the different methods in which they started storing the data. Okay, we know student details is there. So how do we how did we store the details? Okay, in those early days. So we used to maintain one register and we used to store and we used to write the names of the students, attendance details, the parent details, the marks list, everything we used to maintain one register and we used to write in that manually, right? So here limitations of manual record keeping, it's very simple, rewriting the student details every year. So every year I'm supposed to write it. Let's consider there is a student, there is a student, some X, okay, let's consider Radha Krishna. So this particular student has been studying from class 1, from grade 1 to grade 10. Every year the detail of the student has to get repeated in the manual record keeping. So inconsistency, like it may incorrect spell names, maybe I write it in a wrong way, maybe the other person, for example, there is a two person with, like Anish, there may be two person with the same name. Initial also may be same, right? So there may be some confusions. Inconsistency will be there. There is a chance that, the register only get lost. Okay, it may get damaged, and manual corrections, while doing the calculations, they may go wrong. And of course, searching, modifying, or it can be in terms of deleting, everything becomes very difficult in case of manual record system. So and after that, what happened is the file system. They came with a concept called file system. What is this file system? File system you have to understand with respect to the chapter file handling. With respect to file handling. File handling, second chapter, please understand that. That means it is not that you're going to right click or you're going to click one, it's going to open one file, right type everything and then you're going to close it, not like that. What is the background with which you're going to open a file? Literally the background information. Okay, so the coding part, that is what you have to understand here. So here in case of file system, okay, we have considered two files here. One is going to be the student file, another is going to be the attendance file. Okay, we need to store both the files also. So of course they've used computer only here, but not in terms of Excel, or don't think in terms of Excel, or don't think of word processor. Please think in terms of the coding part, how we literally open a file and close a file, write the contents, view the file using that. Later is an application program through which you will be accessing it. Finally is through that only. Plus, in order to understand these limitations, you have to recall those concepts. So we have two files. I have created a file called student file. I have created a file called student file and another student.txt, like that. There is a file called student.txt. There is another file called attendance.txt. So in this In this student file, what all the details I have? Roll number, S name, DOB, date of birth, G name, guardian phone number, guardian address, and the guardian unique identity, some Aadhaar ID, let's consider. Attendance date, roll number, yes name, attendance status, these are the details. So now what are you supposed to do? I have maintained two separate files. Let's consider I've used a list. I've used a list to store all these details. Okay, and I've used a list to store all these details. What is the problem with this now? We have a lot of problem with this also. What are the limitations? Difficulty in access. I've stored all. So I've opened what is a file as a named area in the secondary memory. This is going to be the secondary memory. There is a file called student.txt. And there is another file called what? Attendance.txt. Attendance.txt. Okay. It is difficult to access, they are telling. What do you mean by difficult to access? Whenever I'm supposed to access this file, I need to write an application program for it to access. I have written a file called using this student.txt, I will be writing it. In order for me to access this file, I need an application program. Okay, I need to have an application program. Let's consider that there is a particular query from the particular teacher, okay, from the teacher, let's say from me only. I want student number, student name, roll number and SDVB. One query is this. Another query, let's consider your physics teacher. They want to know the GUID and G address and the G phone number. They wanted to inform some information. They want to pass on some information to your parents. So they want this information along with the student roll number. The query is different. Each time the query is different. Each time we need to write an application for that particular query. See, my query will be different from the physics teacher query and another student. Let's consider the student only. Student only wants some information. The admin is telling, to get some information. So the requirement for each and every user, it varies, no? For example, let's parent only want to have some information. Okay, they want to know the attendance details of a particular student. Their word, okay, it is different. The query keeps varying. As the query keeps varying, every time an application program has to be written. The programmer cannot anticipate all the different types of queries. No, that's why we say in accessing is difficult in accessing. And what is data inconsistency? Data inconsistency because this file is maintained by the class teacher. Okay, this attendance is basically maintained by the class teacher, and the student details is maintained by the office staff. The format in which they have created this file may be different. The format in which they have created the file may be different. Maybe it is like they've used different data structures only. They would have used dictionary here, they would have used a list here. Okay, they may be that the same name only. Okay, there's the same name only. Let's consider that I've written some name Anish here and they would have written Anish space B, something like this. Spellings may be different. Okay, they would have made some changes, then definitely it leads to inconsistency, updations, modification, any kind of searching also. It may come up. It is not that it will come, it may crop. That is what the meaning here. Data inconsistency because both the files are handled by two different users. Similarly, we have data redundancy. You can just see here, similarly in data, roll number is same, S name is repeated. So here the data is repeated again and again. Roll number is enough, S name is again repeated. Redundancy means duplication of data. So when there is a duplication of data, definitely there is a wastage of memory. Wastage of memory will also lead, like it takes more time for you to process also, no? When you have more information, it takes more time for you to process. Okay, it takes more time. Memory is also wasted. So you need to reduce the redundancy. Okay, it is redundancy and data isolation. There is no link. There is no linking or mapping between these two files. Is maintained by the office staff and this is maintained by the respective teacher. There is no link between. If I want to combine the information of attendance of Radha and I want to have the attendance status of a particular student, address of the guardian address and the phone number of the guardian. I cannot combine. Get the data from this file. You know how to get the data from this particular file using the file handling technique. Get the data from this file, combine the data and then you need to retrieve what you want. It's such a complex task. Okay. Data isolation means linking, mapping, relationship between the two files. It is not there. That is what you mean by data isolation. Data dependence. Data dependence means what? For example, I have written while storing the data in this particular file, I've used list. Okay, while in the application program, I have to use list only. If I change the dictionary, I have to change there. So whatever the changes, you've already written a program in list and now there is an advanced data structure, I have to change my data structure means again the application program has to be changed. There is a data dependency between the application program and the backend where we have stored the actual data. Okay, so there is a dependency of data, that's what I can tell you. Okay, control data sharing. Control data sharing means what? Data sharing should be done in a controlled way, okay, depending on the role of the user. So who can use this? Who wants attendance details? Parents want it, teachers want it, student wants it, student don't want. Okay, they don't want any attendance details. Please allow us to write the exam, that is more than enough, and give us the marks. Right? Yes. Okay, so we have different types of users, students, attendants, students, teachers and parents. So here, for each and every user, the authority or the access level should be different. For example, student want to get the information of attendance, definitely he should be given with the, with the accessibility of only read mode, not the write mode. If we give the write mode, he will change the attendance status. Absent, 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 everywhere they put present, present, present. So only reading capacity should be given, reading accessibility should be given, not the writing accessibility. Parents also should be given only the reading accessibility, not read-write mode. Read it as well as write it means they'll also change the attendance status of their words, they will change everything, right? So that also you should ensure controlled data sharing is very, very important. Whereas teacher can change it, they can upload it, they can change it, they can read it. Many features will be there depending on the different kinds of users. Okay, so we'll just go for the real life applications of the database here. So now, so many limitations you've seen in the file system. Now comes the database. So many limitations are there. If you talk about database, all these limitations they have overcome. What is database? Database is a logical collection of huge amount of data wherein it is easy to store, easy to retrieve, easy to manipulate, and easy to access the data is called as database. What is database? It's logically collection of related data wherein it is easy to store the data, easy to retrieve the data, easy to manipulate the data. Okay, you need to have certain application software for you to access this data from the database. That is called DBMS, Database Management System. What is DBMS? Database Management System. So DBMS, what are the different applications? Banking, crop loans, inventory management, product details, customer orders, okay, organizational management, online shopping, okay, any example, real life applications of database can be given. Okay, then there are some key concepts in the DBMS. I think you have understood what is DBMS. Database Management System. What is Database Management System? It's an application software that enable you to create the database. Application software that enables you to create the database is called as Database Management System. MySQL as the Database Management System is an application software that enables you to create the database. That is DBMS. So what are the key concepts in DBMS? So we have database schema, the overall structure of the database, the entire structure of the database. So here which includes table name, what exactly a table, okay, what are the columns, what are the data types, constraints, relationship, everything is clearly explained in this. The overall structure of the database is called as database schema. Constraint means what? Rules and regulations. Rules and regulations. What are the rules? Age cannot be negative. Marks cannot be greater than 100. Okay, so certain rules and regulations that is set for a particular column is called as a constraint. Is called as the constraint. So if mobile number, it should be 10 digits only. It cannot be more than that. That is a rule. That's a rule. Okay, so roll number should be unique. It cannot be null. That's one rule. It's called as primary key constraint. Okay, we'll go for the metadata or data dictionary. Data about data is called as metadata. Data about data is what? Let's consider we have one example here. So we have taken roll number. Roll number 1, then we have Radha here, then we have a date of birth is what? 210 and then 2015, and we can have all these. This is data, this is metadata. Roll number, S name, DOB is the data, is the metadata. Actual data is what? Radha's details is actual data, whereas roll number, S name, SDOB is the data about data called metadata. Okay, and then it's also called as, it is basically stored all these things in a data dictionary called the catalog also we will call it, and database instance. Okay, what the snapshot of the database at a given instant of time. The entire table we have, at entire table initially no data is there, that's an empty data. That's one particular time, what is the status of the database. The status of the database, at the state of the database at any given time is called as a database instance. Okay, I have a table. Initially, it is empty set. And after 5 minutes, I'll enter my details. Then I have one tuple I have. Then after 5 more minutes, I'll enter 10 tuples. Then I have the day status is different. So each and every time the database, it keeps changing. It may change, it may not change also according to the requirement. So every time, okay, what is the state of the database? That is snapshot of the database at a specific time is called as database instance. Query means what? It's a request. Okay, request. Request to retrieve some data. Request to retrieve some data, manipulate some data is called as querying the data we call. Data manipulation means what? Operations. What are the operations that you perform on the database? On the tables, what you can perform? You can insert the tuples, you can insert some records, you can delete some records, you can modify some records. That is what you mean by data manipulation. Database engine is basically the software core component. Okay, so in the entire bus, a bus is moving, but actually which is the component in the bus which is actually driving, engine we call, no? Like that in the entire software, in the entire DBMS, which is the main software that is actually driving, that is actually processing, that is actually managing the data storage and retrieval, that is called a database engine. Which core component in the DBMS which is actually driving the database, which is actually managing, which is actually retrieving, which is actually storing the data, that is called as database engine, driving. Okay, we'll go for the next. Some key terminologies in the DBMS. Okay, we'll just understand some definitions here. Attribute is basically a column. Each and every column is identified by a distinct header. That is called attribute, column or a field. Tuple is basically row record. This is basically what? Roll number. Okay, so roll number, S name, DOB is the column. Distinct name is there. No, these are the attribute, column or the field. Radha, Krishna, details. That will be the tuple. Each tuple, each row is called as a tuple, row or a record. Okay, so then we have a domain, a set of valid values for each column, set of values. For example, date of birth is going to be 2015, 2016, 2017, 2018, something. Okay, some date of birth will be the set of values for a particular column is called as the domain, and number of attributes in a table is called as the degree. Degree means what? Number of attributes. So how many attributes are there in this table? In this table, we have totally 4. 1, 2, 3, 4, 4 attributes. The degree is 4. What is the degree of this? What is the degree of this? Comment it. No, I don't do comment. So 1, 2, 3, 4, 5, 6, 7, 7. The degree is 7. Degree of this particular table is going to be 7. What is cardinality? Cardinality is the number of tuples. What is the cardinality of this? You tell me. What is the cardinality of this particular table? Ma'am, what you have entered? You have entered only half. You have entered only half. But let us consider. Consider as one tuple. So this cardinality is going to be 1. Cardinality is going to be 1. Cardinality is what? Cardinality is basically the number of tuples, the rows in a table. Okay? So we'll just go for the next. We'll just go for this. Key is in relational database. It's very, very important. We'll just go for this. So what do you mean by candidate key? Different types of keys are there. See, key is basically an unique attribute which identifies the tuples uniquely. I can say that. So what is a key? Key is basically an attributes which uniquely identify the tuples. An attribute which, one attribute or multiple attributes, any number of attributes. One attribute of multiple attributes which uniquely identify the tuples is called as a key. Okay, that means all are unique only. So all should be unique. Then how does it make a difference? We'll understand. So candidate key is basically an attribute which uniquely identify the tuples in a relation, but you should understand that each attribute should be, it should be, then what I can tell you, redundant attribute should not be there. There should not be any redundant attribute. That means repetition should not be there. What do you mean by that? Okay, so let's consider that we have a table. I'm going to consider this table called student table. Okay, we have a roll number, S name, SCOB and GUID. Okay, and I'm going to consider the mobile number also. I'll consider mobile number of the student. Yes, mobile number I'm going to consider. Okay, so in this particular table, student table, this attribute uniquely identifies the tuple, this. That means roll number will be unique for each and every student. No, this uniquely identify the tuple. This also will uniquely identify the tuple. I cannot combine this and this will uniquely identify the tuple. I cannot combine like that. Can I combine these two? No. The candidate key means the key which uniquely identify the tuples individually. You cannot have a redundant attribute as such. That means this is one candidate key, this is one candidate key. If I take a student email ID, that is also one of the candidate key now. That is also one of the candidate key. And out of all these candidate key, one key will be selected by the database designer to uniquely identify the tuples in the database. How many candidate keys are there in this table? The first table, roll number, and we have S mobile, right? Now, similarly, I can have student email also, I can have it, student email also. We have 3 candidate key now, we include that. Now, out of these two according now, okay, out of these two, one has been selected by the database designer to uniquely identify the tuples. Roll number is considered. So this will be considered as the primary key. Can this be selected? It can be selected, but it is not selected. No, if it is selected, then it will become a primary key. What is primary key? Is the candidate key which used by the, chosen by the database designer to uniquely identify the tuples. Then what about this? This is also candidate key, but is not currently selected. It can be selected. That's why it is called as alternate key or secondary key. That's why it is also called as alternate key or secondary key. Alternate key or secondary key we call it. Alternate key or secondary key we call it. Okay, remaining candidate keys will become alternate keys and secondary keys. What is composite key? So we'll just understand what is composite key. So you can just understand here in the second table also, we have a GUID, GNAME and GPhone and GAddress. So this can uniquely identify the tuple. This can also uniquely identify the tuples, but one will be selected. This will be the primary key, PK. This is the primary key, PK. Now you tell me, I'm talking about the composite primary key. 2 or more attributes which uniquely identify the tuples. Not a single attribute cannot uniquely identify the tuples. At that time, combination of attributes can uniquely identify the tuples. Okay, so now how? So attendance date, today's date. Okay, let's consider 14/10/2025. Okay, so this is going to be today's date. Okay, roll number, his status I want to know. Yes, present. Okay, so let's consider 14/10/2025, 02, present. Okay, then I'm going to consider 14/10, okay, 15/10/2025. Okay, I'm going to consider 01. Okay, he is also present now. That means you cannot consider attendance date as uniquely identifies the tuple because 14/14 it is getting repeated. For different students, the same date gets repeated. And here for same students, different date also we can have. 01/01 for the same date for different dates. 01/01 for different date, 14th and 15th. That means roll number also will be repeated and attendance details also will be repeated. So uniquely, this cannot separately identify the tuples uniquely. This also will not, to have a combination for it to uniquely identify the tuple. A combination which uniquely identify the tuple, that becomes a composite primary key. Composite primary key. Is the point clear? So this should understand now. So we'll just go for, okay, I'm just going to consider this. Okay, next is going to be the foreign key. What is foreign key? Foreign key is used to establish a relation between the two tables. I told you in the file system, there is no linking, there is no mapping. There should be some kind of relationship between the tables, because if with one table, I should be able to access the other table also. That means if I have a student table, I should be able to access the attendance. If I have a student table, I should be able to access the guardian details. So like this, the one table and the other table should be linked so that I can combine and get the information. Who is doing the job? Foreign key is doing. You can just consider for this table is going to be the primary key, and GUID is the foreign key. What is foreign key? Foreign key basically is an attribute in one table, refers to the primary key of the other table. GUID is basically a foreign key here, is an attribute that refers to the primary key of another table. This is the primary key for this table, which refers to the primary key of another table, which refers to the primary key of another table, establishing a relationship between the two. Using this, it establishes the relationship between the two tables. This is the primary key, this is the foreign key. This is going to be the primary key. Clear? Understood? You have to understand this. It establishes the relationship between the two tables. Okay, and okay, we'll go for the last slide of this particular chapter, that is called as relational data model properties. So what is data model? Data model is basically describe the entire structure, entire schema. Data model is basically that gives the overall structure of the database. Basically, what is the table, what are the attributes, the data types, and then what are the constraints, what are the relationship, everything is given by this data model. If this data model, everything is written in terms of tables, be it a table, be it a metadata, be it constraint, be it anything, be it a relationship, everything is expressed in terms of tables, in terms of rows and columns. That is called relational data model. Data model represented in terms of table is called as relational data model. Understand here, relation means table. Relation means table. Clear? Relation means table here. So what are the rules that we can apply on the relation? What are the rules that we can apply on this relation? What are the rules? What are the properties or the rules of a relation in the relational data model? Relational data model is the entire structure of the database, is given in terms of tables, and what are the rules that we can apply on those tables, on those relations? Relation means tables. Understand that. What are the rules? So there are different rules. So you can just consider any table. You will have one attribute, you will have one tuple, you will have one values. Attribute will be there. Hope it is clear to you. Okay, you will have an attribute. You will have a tuple, Radha tuple, Krishna tuple, then Anirudh tuple, Anish tuple, like you will have some tuples, records will be there, that is a tuple. Values, each value, Krishna is a value, tuple is the whole entire row. Anish is one value, Radha is one value. What are the rules on these? That is what is explained here. Okay, rules. So what is that? The attribute must have a unique name. Each and every attribute should be unique. The order of the attribute doesn't matter. I can write yes name here, roll number there, roll number at the end also I can write. Order doesn't matter. Simple for the attribute. What is the rule of tuple? Each and every tuple should be unique. Radha tuple should be unique from Krishna tuple. At least by one value. How you are ensuring it is different? How you are ensuring that the two tuples are different? At least by having the primary key. Primary key should be unique and it should be not null. At least roll number will be changed. No, let's consider that they are twins. Okay, Radha Krishna, they are twins, let's consider. So here we have name of course it is differing. Let's consider Radha only. So then name is same, SDOB is also same, maybe, okay, GOID also same, all the twins if I consider, then everything is same. At least the roll number will be different. That's how it is considering that, ensuring that the tuples should be unique and the order of the tuples doesn't matter. I can write Radha tuple first, then Krishna tuple. Any tuple order doesn't matter here at all. Okay? Similarly, we have the rules and the values. What are the different rules? We have different rules on the values. It should belong to the same domain. Each and every value, for example, date of birth of a particular student, it should belong to int only. It cannot be float. I cannot write in terms of float value. I cannot write in terms of, I cannot write the date of birth as 14th October 2025. No, I can't write like this. If you have to follow a particular format, there is a particular data type. Means you should follow that format only. Date you've used, particular format of date only should use. You cannot just change the order or change the data type of it. It should belong to a particular domain only. So numeric type only, you cannot have strings. And it should be atomic. It cannot be divisible. It should not be divisible. Let's consider that what is the example they've taken. Phone number. Phone number should be single value. Rather than a phone number, we'll take a name. For example, there is a name called, what is the name I can take? Let's consider, what is the name I want to take? Okay, so Anish Shankar Gupta, something like this. What is this? Okay, some name I've taken. Anish Shankar Gupta, some name I've taken. That means this name can be divided. So such name should not be taken. That means you have to take it as the first name, middle name, and then the last name. It cannot be divisible. Take the values in such a way that it cannot be divided. So like that it should be. Okay, that is what the meaning of atomic means. No multi-valued. I cannot take two phone numbers. One number means one number only. I cannot take multiple values here. Phone number one, take a different attribute for storing another alternate number, but not one attribute having multiple values. It cannot take, and null value can be used. For certain attributes, it can take null value. Null value means it can represent unknown value, not applicable, missing data. So many values, so many meanings it has null value. So it can take null value, they are telling. Okay, so that's all about this entire database concept. So we have completed the entire revision for the midterm examination students. So if you have any doubts, any kind of challenge if you're facing in computer science subjects, you can definitely post some comments. We'll definitely keep in touch with you and we'll definitely get back to you. Thank you so much for the cooperation and the support. Thank you.